All right. So I hope all of you are having a good Sunday. Uh, so I'm going to start with the basic recap of what we have done last time. I know we have stopped at matrices and stuff, but today's class we are going to do a lot of visualization, and we're going to cover the packages in Python mainly. So last class you all have created a project. You've seen how to install the packages and stuff, right? You've installed pandas, you've installed matplotlib, you've installed Seaborn. So today we are going to do that. We are going to mainly cover. I don't think if we have time, we'll cover the video game sales case study. But today we'll be mostly limiting to the Indian liver patients case study. So like we'll go through all the basic steps of what data engineering is. So the goal is to cover by end of this class and the next class. We're going to start looking at how to make the data ready for feeding it into an algorithm. So before we start into like the visualization in Python, I think I just basically touched on what NumPy is and stuff. But let me finish off my lecture on matrices. I think we stopped last time when we started matrices, and then we didn't get through like uh, complete the math behind matrices. So first and foremost reason, right? Like whenever so let me just bring up the Indian liver patients case study. So whenever you have the data, so this is the CSV file. The first thing is every observation. So this is so this is our case study which we are going to look at. But if you look at it, so every row is one observation, and then the end row which says dataset is either having a label 1 or 2. So label 1 means that person does not have the disease, and label 2 means that person has the disease. But every row again is an observation, and every observation consists of what are these things? Like we have like 6 to 7 sets of columns here. So what are these? So what does an observation consist of?
It's a feature.
It's a feature. Uh, I think I think I gave the remote control to Raghav by mistake. So Raghav, you can just disable that remote control because you're able to control my desktop now. So if you can just leave, no, you're controlling my desktop right now. Let me see if I can about control. Okay, cool. Yeah. So every observation consists of features. So basically, for a machine, every observation has to be defined by a set of features. So that is the first and foremost important thing. Like, how do we choose these features? Because, like, for us humans, we see something, we actually can make a mental image of it. For us, maybe we think in terms of images, but if you look deep into like what we do from an image is we extract features from an image. So the machine cannot, even you give it features, you give it images, you give it any other thing, the first thing which a machine looks at a data is the number of features. So for example, each observation here, like, okay, we see that it is 65 years old female with such and such bilirubin count and stuff, and then we tell the machine that, hey, this person does not have the disease. So the reason why we are studying matrices is because all this data is can be formatted in terms of a machine, in terms of a matrix. So let me just draw something here. So what we have seen last time, I'll just repeat it again. So basically what happens here is we have first observation, right? So basically we have age, we have gender, we have other feature set. So feature set here. And then ultimately we have the label for this. So each of this is one particular point. So in case of an observation, so like each of this observation can be represented as 62 female, and then different values for everything. So if you have a lot of observations like this, all this can be put in a matrix. So all these observations can be put in a matrix. So you actually have a matrix where each of the row in the matrix will determine the feature set of each individual one. So basically, ultimately, what is our goal? Our goal is to predict this label, right? Because this is the training set. During the training, we actually tell the machine that, hey, for this observation, it is basically, for this observation, he has a disease or does not have a disease. But once a machine learns the model, the next step is to give it some more data and ask the machine to predict what that label is. So the way we are going to formulate this problem is by saying, so ultimately we need to have something like this. We need to, so ultimate goal is to predict this label here. A label is nothing but either 1 or 2 or 1, 1, 1, 1. So, and then this is our matrix X. And this is our matrix. So we need to find out if we can find some operation which can multiply with this matrix X such that you will get this particular vector. So the reason for that is, let me just cover this again. So I think last time I asked this question. So if I give this data, if you take this particular thing, so look at this data here. I give you some X values and some Y values. So now X is given and Y is given. So first thing, what, like if I give you these values and then I ask you like, okay, X equals 50 is not there here. Can you find Y when X equals 50? The first thing, how would you go about doing that? The first thing is to put this thing into a particular model. So if we assume that the data is linearly related, then what we try to do is we try to come up with a formula which is, oh, I think I have to switch between these shares. Okay. Close this.
Sai, the control is with you, right now?
Yeah, its control is with me. Yeah. So switch between the shares. So let me go back to the share. So here is the data. So when I give you some X values and I tell these are the Y values. So for which, so if X equals 50, find Y. So the first thing we will do is we'll try to fit a linear equation, which is Y equals mx plus c between the points which we know and the points which we have. The idea is to find the best m and b, right? So when we actually look at an equation of a line, what is the equation of a line? Generally, we represent it as Y equals mx plus b. So we given this data, so this is our training data. From this training data, we try to predict what the values of m and b are. And once we've actually got the optimal values of m and b, then we say our training is done. So then what we do is we ask for test data. In the test data is X equals 50. We just plug it back into that equation and find what Y is. Is this thing clear? Is this concept clear? So basically what we try to do is whenever you have some data like this, we try to represent it as like, I mean, mx plus b or ax plus b, they're just variables. We try to find an equation which is y equals ax plus b here, where we don't know what a and b are. But what we know is we have x and y. So given these x and y, we try to predict what a and b is. Once we get the best values of a and b, then then we say that the machine has learned this model. So it has learned the linear equation of the line. So for a new value of x, you just have to plug it into this particular equation. You will find what the value of y is. Is this example clear? Is there any questions on this?
Actually, it's not clear, sir. Like, I'm just trying to, I mean, this equation, right? Like, ax plus b equal to y.
Yes.
Right?
Yes.
So there are two variables, a and b.
Yes.
And then, imagine if x value is 20 and y is 68. It's like 20x plus b equal to 68, right?
Yes, yes.
So it's basically, it's still in the linear form, like,
it is still in linear form. So basically you need two equations, right? So basically you have two unknowns. You need at least two values to fit, because it's like solving like linear equations, right? So you will put x equals 20, y equals 68. That is still one equation. And next time you will put x equals 25, y equals 77. That is another equation, right? So now you have two values and two equations. Then you will solve for a and b. Like in basic linear algebra, when you have two unknowns and two equations, you can solve
Yeah,
for
yeah.
A and B
So
are.
basically, are we saying like equation 1 equal to equation 2?
Not equation 1. Basically, you're trying to formulate what is the best model which can
Oh,
fit this A and B. So you won't exactly get a line. So because this data is exactly not linear, what you will do is you will try to predict a approximate linear model for this particular thing. So for example, let me again show you this. So if you actually, let me clear this thing. So ask as many questions as possible, because these are the basics of machine learning. If you know these things really well, then when we do supervised learning, unsupervised learning, you will actually understand what we are planning to do there. So basically, you have some points like this, right? Here I said x equals, this is x-axis, this is y-axis. I said for x equals 20, y equals 68. So maybe some point here. You have more points like this. So basically, I am saying that for learning this particular, so this is a linear model. So we don't know if, how will we know if whatever model we predicted is correct or not? Because we always test our model. If we test our model and the accuracy is really bad, then we'll think that this model is bad. So, but for now, initially I'm assuming that it's a linear model. So there are different points like this. So basically, if I take 2 points, I can get one line. But what we'll try to do is that's what we will discuss later on. But we'll try to get an approximate equation of a line, which is need not be passing through all the points, but it is approximately in the same, it's following the same trend. So now I will find out so this line is ax plus b. I'll find out what A and B are using these points. And now I say that the machine will learn what A and B are. So now the training is done. So training is whatever points I gave you, that is done. So now what I'll ask you, I'll give you test data. So I'll say when x equals 50, can you predict what y is? So you will put this x 50 in this equation, and you will get the y predicted. So generally so this is called the error, y minus y. This one is called the error. So we will try to, so that tells us how good our prediction is. But in general, you get this thing, right? So whenever you have some data, you try to predict a linear model, and then you try to see what the actual error is. But we'll take one step at a time. So the reason why we are actually doing this matrices is because you have all these linear equations. So you have different features, right? So if I actually show you, can you see? So can you see my screen and the dashboard together, or should I kill the dashboard to show the screen? So now are you only seeing my
correct. We are only. I'm seeing only your dashboard.
Oh, okay. Then I think I should just kill my dashboard to see this thing. So here. So now you see that these are all the these are all the data you have. So what I'm trying to do is I'm trying to predict what the label is, taking these. Now instead of 2 dimensions, like instead of having one x value, I'm having a really big x, which is 65 female, 0.7, 0.8, and all this thing. So this is all my 1x value. So basically the model is becoming like this. So we are trying to get something like this one: a1x1 plus a2x2 plus anxn equals b, where b is your label. And so this is just extending it. So in case of x and y, initially that was just 2-dimensional space. Now it is an n-dimensional space. So basically you have like n features, and for each of the feature you have to find out what these coefficients are: a1x1, a1 up to axn. You'll find out what these things are given the label. So it's similar to a linear equation problem, but we are trying to formulate it for all these features. So the way we are trying to formulate it is like this. So we put all these x values into one and labels into one. So now this is a matrix, right? All these x values become a matrix. So then we try to formulate the problem as, ax equals b, where a is a matrix which we need to predict, where a contains these values: a1, a2, an.
Shouldn't it be a and xn plus b equal to y?
So yeah, sometimes basically you can actually predict it. I mean, to optimize it, we put this thing. But what we have done is we have taken that the b there and then made the like it. You're right. It should be plus b equal to y. But if you actually take the b to the other side, it will be y minus b, right? So you'll take that as the. It's just so that the matrix form fits well.
Okay.
So you just subtract it and then call that as b. So you're right. I mean, but then that's just an optimization which we do in the maths to show that that is the case. So we defined so this is the problem which we are trying to solve. So that's why we have to learn matrices. But there is other use of matrix also. So basically, when you have this vector, right, a x equals b, you base. Let me show you this thing. So we did this last time. So what is the difference between a vector and a matrix? I think I covered it last time. So just a vector and what is a matrix? A vector consists of each individual scalar values. So like for example, each house, let's say if it has 5 features, then if you comprise all the features into one particular vector, this is called a vector. For example, in our case, each individual patient's feature value is a vector. So basically, then we can say that this matrix consists of, so each one is a vector, right? So this is one vector, this is the second vector. A matrix consists of series of vectors. So is that clear? What is a vector and what is a matrix? A matrix consists of a set of vectors. So if we go ahead and then see, if we take, like for example, if you're taking a house, right? I actually told you, like, let's say we extract 5 different features from the house, like the square footage, number of bedrooms, number of lawns, which year it was built. So we can actually make that as a vector. So in a 5-dimensional space, each house becomes a point. Is that clear? Any questions so far? Everyone understood why we are trying to formulate it as a matrix?
Yeah.
Okay. So each house, we can actually take it as a metric, as a vector. So there is this concept. So the main reason why we are even studying these matrices is because we need to know which features should we take. Now we have like so many features, right? So we have like bilirubin count, we have alkaline phosphate. Do you think all of them actually contribute to this particular thing? Because when you ask a doctor, he'll give you a lot of features. You go to a medical doctor and you say that, hey, I'm trying to write a model which will predict if a person has liver disease or not. Can you give me all the data you have? I think that's the same problem with even if you're trying to this is a completely unknown problem. You're trying to write a machine learning model. Like for example, you have to predict the sales of a particular company of certain video games. First thing what you'll do is you'll go to your manager or someone else in the team and say, hey, I want to write a model for this. Can you give me the data? So now in the data, the doctor will say, hey, I have all this data. You take all the data and then write your model. But is every feature in this data useful for you? So you can't say that, right? Because you can sometimes, looking at it, you can probably predict that, because when I showed you the graph yesterday, not yesterday, last class, I actually showed you a graph, a scatter plot. Let me show you that again. So by the way, we'll be writing this today. So I just wanted to show you. So I just took 2 features here. Let the plot finish. So I just took 2 features, which is the bilirubin count and alkaline phosphate count. Looking at these 2 features, we can say that people with the disease and without disease can be differentiated by just taking these 2 features. Similarly, you have to take all the columns and start plotting these graphs. That's not properly viable, right? Like let's say if someone gives you like 1,000 features for each observation, you can't sit and say every 2 features I'll take and then I'll decide. So there should be some way for us to predict how to actually choose those features, and that comes from the matrix algebra. So let me just cover this in. So how many of you remember inverse of a matrix and stuff like that? Maybe you've done it in high school. So I won't go into the depth, but I'll tell you why that is important. So that is because, okay, so we know now, we learned what the scalars and vectors are, right? So a scalar is each individual point in a vector is called a scalar, and a group of scalars is a vector, and a group of vectors is a matrix. So then every every vector has a magnitude and direction. So we can say that if two vector points, if a point a1 and a2 is there, which is the magnitude of that point is square root of a1 square plus a2 square, and then there is a way to find the direction of that component and stuff. We don't need to deal with everything in that detail, but the main operation which I wanted to show was, so we have like vector addition, we have vector subtraction. This is pretty straightforward. But the main thing which you actually take away from this is linear independence and linear dependent. So what is linear independence and what is linear dependent? So I'll give you a small example for that. So let's say you're looking at housing data, right? So now in housing data, you have to write a model, a machine learning model, which will predict the house price given certain features. So you go to the real estate agent and say, hey, I want to create a machine learning model for Seattle market. Give me all the data you have. So he will give you, okay, this house has these many number of bedrooms, these many number of bathrooms, this many number of, this is the square footage of the area and stuff like that, right? So then what you will do is you'll try to formulate, like put each of these as a feature vector in your data. But like in this case, so let me ask this question. Number of bedrooms and number of bathrooms, do they provide same information, or do you think they provide different information about a house? So like you go to a real estate agent and he'll give you one feature is number of bedrooms, other feature is number of bathrooms. Do you think like both these features say the same thing about a house, or do they say different things about a house? Different, right? Because number of bedrooms and number of bathrooms give you exactly different features about the house. But now let us say he gives you the total square footage of the house, and then he gives you the square footage of the bedrooms. Is that giving same information, or is it giving different information?
One's incorporated in the other, suppose.
Exactly. So in this case, one feature is actually incorporated into the other thing. So that means that these two features are linearly dependent on each other. When can you say a feature is linearly dependent on each other? That's why we need to learn these vectors here. So when you get one feature which can be expressed as a sum of two other, or a linear combination of two other vectors, then you say that this feature is linearly dependent on A and B. So for example, in this case, A is a feature, B is a feature, and somehow someone gives you another feature which is A plus lambda times B. So will you say that the new feature A plus lambda times B, is it dependent on A and B or independent of A and B? Dependent, because
you're multiplying A and some lambda to B.
Exactly. So basically, when the key takeaway from this is, for a good machine learning model, all our feature sets need to be linearly independent of each other. That is like underline this and then like memorize this, or like if you have like a cheat sheet, whenever you're doing data engineering, make a note that you should always choose features which will give you additional information about a particular observation. If you are choosing a feature which is basically giving the same information, that means you're adding more noise to your system. Like in this case, when I'm trying to like predict a housing market, this thing. So you can see that when like for example in housing data, the number of bedrooms and the number of bathrooms are two different informations about the house, and you cannot be ignored one for the other. If two or more vectors are linearly dependent, then one can be represented as a linear combination of other vectors. If one of them can be dropped from the analysis, we won't be losing any further information. For example, in housing data, if one has the square footage of each room, then no need to mention the total square footage. Is this thing clear? So this is the fundamental of data engineering. Is like, so there are two ways we'll actually look at it. I'll talk about PCA later on. But then whenever you're getting all this information, you shouldn't be. Sorry, was there a question? I heard someone say something. Sorry, can you repeat it? Okay. Deepika, was it you? Did you have a question?
Oh, no, I did not have a question.
Oh, okay. Okay, I actually thought someone was saying something. Anyways, is this thing clear? The first and fundamental thing which we need from feature engineering is the features which you extract, or if you want to formulate a problem, each feature should tell you something new about the data set. If you're including features which are linearly dependent on each other, then the thing which you're feeding to your machine learning algorithm is confusing. Like the simple example for that is that in the housing data, number of bedrooms and number of bathrooms are linearly independent of each other. But if you're taking the total square footage of the house and you're saying each individual square footage of each room, that means total square footage actually has this information included, right? So that means they are linearly dependent on each other. So that you should avoid taking features which actually have a linear dependence. So linear dependence can be used in dimensionality reduction of a problem. Instead of dealing with 100 different parameters of a house to determine the price, we can only find 50 such that they're linearly independent of each other, and the rest can be dropped from calculation. Is this slide clear? Because if it's not clear, I'm going to explain it again, because this is the fundamental of data engineering. So how do you choose the data which can actually explain your model better, on which does not confuse your machine learning algorithm? So is this clear?
Yeah.
Okay. Anyone else? So basically, since I'm not able to see you guys, if you're having questions, please stop and say or ask me at that particular point of time, because in my head, if you're not saying anything, I'm assuming that you're understanding. So even if you're not following even for a bit, stop me and ask me. And if at all you're understanding it, it's just as a feedback to me, just say yes or no, so that I can gauge at least that you're following. So to repeat again, so we are actually trying to formulate. So in this particular case, now let's go back to housing example. In the house, sorry, not housing, the liver patient example. So we have these different features, right? How do we know that? Okay, now how do I determine this? Now will I try to see that, should I try to see alkaline phosphate if it is a linear combination of bilirubin count and direct bilirubin? So we can't sit and make this math, right? So that's why we are learning this matrix algebra, because at the end of it, the matrix algebra will tell us, like, if you're choosing features which actually have linear independence or linear dependence. So for that, initially we might not understand why are we learning this addition of vectors, subtraction of vectors. So the reason we are doing addition of vectors is because if any feature which can be represented as a plus b, then that means that it can be expressed as a linear combination of a plus b. So that's when we say that it is this particular third feature is actually dependent on a and b. So, but the main thing, I know some of you are still in school. So can someone tell me what is the best operation to say if two vectors are dependent on each other or not? So if two vectors are completely independent of each other, or at least tell me, if two vectors are completely independent of each other, what would be the angle between them? Slightly confusing, right? So basically that's where we come to the dot product. So the dot product of two vectors is expressed as, I think maybe if you're teaching your kids or someone, you'll be teaching this in linear algebra to them. So two vectors, their dot product a dot b is expressed as magnitude of a times magnitude of b times cos of the angle between them. if two vectors are completely independent of each other, the angle between them is 90 degrees. I think intuitively you should understand that fact now, because I think let me just show you this. So let's say we have clear all drawings. So let's say we have. So why do you think we actually have this coordinate system where you have x-axis and y-axis? What is the angle between x-axis and y-axis? It's 90 degrees, right? So whenever we draw x-axis and y-axis, we draw them perpendicular to each other. That is because there is no component of y in x and there is no component of x in y. So if you see, they both are like, but if I draw some other axis which is like this axis has some component of y and some component of x. Are you following me? Like, let's say, why are all the axes 90 degrees? Why can't I have one axis which is like this? Why can't I call this x-axis and call this y-axis? That's because there is a certain portion of this axis, this whatever this axis is, can be, because you have an angle, right? It can be projected onto this. This is y cos theta. If you go back to basic trigonometry, there's a certain portion of this particular axis which can be expressed in terms of x, and there's a certain, so that's why whenever we have like coordinate geometry and stuff, we always look at x and y axis which are like 90 degrees apart, which means that this x component and y component don't have any information they can share, because of, if it's tilted a little bit, you can see that the angle is not 90, so there's a certain component of y axis in x axis, so they're having some linear dependence. So now do you understand why do we, so even when you talk of 3D geometry, right, when you have x-axis, y-axis and z-axis, all of them are 90 degrees to each other. So this is 90, this is 90. The reason being, like, each component needs to be independent of the other. There shouldn't be any, because if you take the projection of this, it's just a dot. But whereas if I take an axis which is like this, are you seeing the dashboard? You are seeing, right? Okay. Good.
Yeah.
Yeah.
You
Okay.
can see my dashboard. Yes.
Yeah. Is this thing clear? Like, this is the basic of math. Like, I mean, I don't know if you're appreciating the essence of it. Like, the reason why we have coordinate geometry and everything which has 90 degrees is because each component says a different thing about the point. Even in x and y, we say x is this much, y is this much. But if I have something like this, and if I try to represent this as 2, 3, that means there is some component of x which you're already using in y. So that is the reason why we say, when we talk of linear independence, the angle between both of them is supposed to be 90 degrees. Is that thing clear?
Yeah.
I'll move forward. So that's why we learn this. And what will give you that angle? It's the dot product of two vectors. So A dot B is given as magnitude of A times magnitude of B times the cos of the angle between both of them. So when you say when theta is 90 degrees, the dot product will become 0 because cos of 90 is 0. In other words, if two vectors are perpendicular to each other, their dot product will be 0. If the dot product of two vectors is 0, then they are called orthogonal vectors. In addition, if their magnitude is 1, they're called orthonormal vectors. You need not know the terminology that much, but this is clear, right? Like when you have two particular features which are completely independent of each other, then the angle between them is 90 degrees and they will be orthogonal to each other. That's why even in coordinate geometry, whenever we talk of x-axis, y-axis, z-axis, and like n dimension, in n dimension, all of them are perpendicular to each other, so that each component represents only that particular feature, doesn't represent the other feature. So is this thing clear? Is everyone clear with what linear independence is and why is it relevant to us? Because we need to find features in any particular model which actually give new data. If you're actually having, there are two reasons. Sometimes it's okay, like it's okay to have linearly dependent features, but you will be processing like one whole column additionally. So let's say if you have 100 different parameters for a house, you actually need to boil them down to 50, because, and how will you do that is by removing all the features which are actually dependent on each other. And how we will get to that is what the mathematics will tell you. Is this thing clear up to here? Is the housing example clear? Like, why is it that we will choose, why don't we choose the square footage of the bedrooms and the whole house as our parameters? Is this clear?
Yeah.
Okay. I mean, I would encourage everyone to tell me yes or no, because because this is like the basics of the machine learning or the data engineering which we need to learn. Is like when, let's say you're starting as a data science engineer in a new company, the first and foremost thing which everyone does is they'll dump the information to you. They'll give you like a lot of data. Let's say, for example, you want to solve a medical, you're writing a machine learning model to assist a doctor. You'll go to him and say, hey, give me your data and tell me with this particular data, give me the labeled set, and I will write a machine learning model which will actually learn from this and then tell you if the other patient has diabetes or not. So doctor, he won't understand. He'll say, oh, these are all the data I have, like all the blood tests, urine tests, all the features. But you have to pick the right features, right? So if you don't pick the right features, then your model will not be the same. And how will you pick the right features? You have to pick features which are linearly independent of each other. So the way, if you have linear dependence, then your model will not work. And that we will see in terms of matrices also. So let's start from what a matrix is. A matrix is nothing but it has rows and columns. In this case, there are m rows. So this is an m by n matrix. This is what we call a matrix. M rows and n columns. So in case of our Indian liver patients, what is the dimensions of this matrix? Can someone tell me the dimensions of this matrix? Because you have the data, right? So if I want to represent this as ax plus b, what would be the dimensions of this matrix, of that matrix X, which I was talking about?
584 by 11.
So that's a total number of rows, which is 584. And let's see how many columns are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is not 11, it will be 10 because this one is what we predict, right?
Yeah.
So we put this out. So the matrix X would consist of 584 by 10. So there are 10 columns of that matrix, and you will see that. So is that clear why this is not included? Because this is what we are wanting to predict. So our formulation, so in our, we only take the features in this particular thing. This is the end result.
Yeah, and then you'll have another matrix like of 584 different variables, I guess. Right?
Exactly. That is not a that would be a vector because it's going to be just, it's A1, A2, A3 up to AN, right? So that's just a vector.
Yeah.
Is that thing clear? Like why we are not choosing the last one? Because that's what we are planning to predict. So if you actually saw my drawing from last time, what we are trying to do is we are trying to find these A1, A2, AN coefficients for each of, so x1, x2, x3, for each of these things, we are going to multiply that A1 times 65. So I'll talk about data modeling. So you cannot have text in the data. So what you will do is gender, you will replace it by either 0 or 1. Because obviously you cannot multiply strings with numbers and try to find something. So you'll try to find A1 times 65 plus A2 times 1 plus A2 times 0.6, 0.7 plus A3 times 0.1, blah, 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 blah. And then ultimately you'll try to say if that thing is 1 or 2, because that is what we are trying to predict. Is this clear until now? Like, why are we even learning these matrices? Why is it that
in the job, like when we get the data set, we have to carry out this operation with some kind
Yes.
of
So basically, first thing you will carry out is you will have to carry out a test which will tell you. First thing is which will tell you whether the feature sets which you have are linearly independent or dependent, and how we'll do that exercise in today's class. And how we do that, I didn't still finish how we are going to do that, but overall, I wanted to let you know that yes, you have to you have to choose features which are linearly independent. And the matrix operation which will tell you if they're linearly independent or not is the determinant of a matrix. I'll get to that in 1 second, in the next few slides. I mean, this, you must have learned this back in like high school or something, but machine learning is all about, the algorithms and everything are all about this basic math, the statistical modeling and so on, stuff like that. So you need to be good at like conditional probability and statistics. I have like the math slides also, which I'll be, I mean, even if you're not familiar with this, we will teach that in the course. But cool. So basically, this particular thing is an m by n matrix, where m is the number of rows and n is the number of columns. M and n need not be equal. Like for example, in our okay, so this is 514. I think I have to put. So in case of our liver patient example, we have 514 rows and 10 different columns, where each column is a different observation. Forward. So then transpose, these are basic operations. So the way we will learn matrices is with NumPy arrays, right? So remember, I actually showed you, I mean, I thought of, I think I introduced what NumPy is, right? So transpose of a matrix. We will do that once. Let me finish the concept behind this. Then I don't want you to get involved in programming as soon as you learn this thing. I'll talk about, we'll do programs to add a matrix, multiply a matrix and stuff. So what is a transpose of a matrix? Basically, if you convert the rows into columns and columns into rows, it's a transpose. Like, so here your row became a column and your column became a row. So that's a transpose of a matrix. How do you add two matrices? You add two matrices by just adding each individual element. So 3, 5, and 7, and 0, -1, and 6. This is one, this is the other one. The way you add them is just by adding 3 plus 6. Each individual, like whatever position each individual element is, you'll just add those two elements together. So that's how you actually add two matrices. Subtraction is exactly the other operation. So subtract two matrices would be 3 minus 6, 5 minus 2, and so on. Then multiplication of a matrix with a scalar. So when you actually multiply a matrix with 5, you multiply each individual element with 5. So, and then comes multiplication with another matrix. So you must have done this in school. So when you have a matrix which is 5 by 7, which is 5 rows and 7 columns, you can only multiply it with another matrix which has 7 rows and 5 columns. So these both numbers should be the same. If you have like two matrices which has like 3 by 5 and 3 by 5, you cannot multiply them, because the number of columns in one row should actually match the number of rows in the other column. That's because, how many of you remember that from school? Does everyone remember that, like why matrix multiplication and stuff?
No, Sai.
Oh,
This
okay.
is a good reminder.
So basically in multiplication, like we actually have to have, if you have two matrices, the reason being the formula, right? Like when you actually multiply, what we do is this whole row will multiply with this whole column. So if you see this, right? So there are 3 elements in this row, 3, 5, and 7. And so this is, so these are number of columns, right? And in the other case, these are number of rows. So how we multiply is 3 times 6 plus 5 times 4 plus 7 times 5. So let's say if this is also like, if this is also the same format, you cannot multiply this row with this column, right? Because if they're different dimensions, you cannot multiply. Is this clear, or? So you have to multiply each row with each column in the other when you're multiplying two matrices. So if the number of rows in this is not equal to number of columns in this, so every element will not have a corresponding element. Therefore, you will get an error. So matrix multiplication is basically when you actually multiply each. We will write this. I think when you write the code for this, it'll become a little bit more clear. But I want to go into like, when someone asks me, when someone gives you the data, like what is it that which will tell me that if I'm taking the right set of parameters or not. So I want to go into that portion so that we'll complete the understanding aspects of the data first, and then we'll come back and code it. But for now, just ensure that when you're multiplying two matrices, the column of Number of columns in the first matrix and number of rows in the second matrix has to be the same, because every number needs to be multiplied with every number here. And the resultant matrix will be 5 by 9. So you can see that here. So this is a what is this matrix? It's 2 by 3, right? 2 rows, 3 columns. This is 3 rows, 2 columns. So you see 2 by 3 and 3 by 2 can be multiplied, because they both are 3, 3. The resultant is again 2 and 2. So you'll see that C is basically 2 by 2. You can see that back here. So if you have a 5 by 7 and 7 by 9, when you multiply the matrix, the result will be 5 by 9. Is this thing clear? Matrix multiplication.
Yes, sir.
Okay. So that's basically multiplication. So basically, so in scalars, right, 5 times 7 and 7 times 5 will give you the same result, but in matrices, A times B and B times A will not give you the same result, because you typically cannot multiply that, because let's say A is 2 by 3 and B is 3 by 5. These both can be multiplied because the columns and rows are the same. But B times A cannot be multiplied because it has 5 columns and this has 2 rows. So it's not a transitive property in case of matrix multiplication. So then comes matrix multiplication, then division. How will you divide one matrix with the other? The division of a matrix is not possible, right? It's not like, oh, you can just divide the numbers together. But there is something called as inverse of a matrix. I think this is a very popular or fundamental term. Inverse of a matrix. So again, let me get my board out here. So I think this probably will be. Okay. So let me actually give you a small mathematical equation. So I have 3 times x equals 6. What is x? Three times x equals 6. What is x?
2.
How did you get that? You actually said x equals 6 divided by 3.
3.
Right? So now I have a matrix. I have a matrix A and the matrix X. Both this multiply and give you a matrix B. So ideally what you will say is, oh, X equals B divided by A. But these both are matrices and matrix division is not possible. So in general, like, no, sorry, this is not possible for us, because you cannot divide two matrices. What is possible is you actually have something called as an inverse of a matrix. It is denoted by a to the power minus 1, or that's what is a denotion. So the property of an inverse of a matrix is A times A inverse will give you the identity matrix. Identity matrix is 1, 1, 1, 1, everything else is 0, 0, 0, 0. Think of it like similar to, like, you know, how you have like fractions, right? When you have A and the inverse of A is 1 by A, right? So you'll multiply A 1 by A, you'll get 1. So similarly in matrix, you'll denote this as inverse of A. So for solving this equation, what you will do is, like, A times A inverse or A inverse times A will give you the result identity. So in case of matrices, when you have A x equals B, what we'll do is we'll try to multiply it by A inverse both sides, equals A inverse times B. So this is what A inverse times this thing is identity matrix, right? This is equal to A inverse times B. Identity matrix times any matrix is always the same matrix. So X equals A inverse times B. Is this thing clear? So we cannot directly, ideally it should be like B times this thing, but the way we do it is by saying we multiply it by A inverse on both sides, and then we say that X equals A inverse times B. So this is identity matrix. Is this thing clear? So we don't have division as such, but we have inverse of a matrix. Clear, right? So if you want to actually find, now let us go back to our problem. So in our problem, we have like these each features, right? So we have X, and then we have to multiply it with the scalar called A, and we have this label B. These are labels. This is a vector, this is a vector, right? Because this is, what is A? A is simply A11, comma, A12, A313, so on up to A1n. So if you want to find A, what will that be? It should be X inverse times B, right? Because of the thing I just showed you. So now comes the problem of inverse of a matrix. Given a matrix X, how will you find the inverse of a matrix? So I'll directly give you the formula because this is not a math class. So basically, inverse of a matrix is 1 by determinant of a matrix. It's called determinant of a matrix times its covariance. So basically, there's some operation here. Basically, determinant of a matrix is what is dividing X inverse. So determinant of a matrix is just one number. Like, I'll tell you how we calculate a determinant. Does anyone see a problem with this? When I say X inverse, it's 1 by determinant of a matrix times another matrix. You need not worry what this matrix is called as X dash. This is a formula. Can anyone tell me when does X inverse not exist? Just look at this formula and tell me, like, when we are taking the inverse of a matrix, it's called 1 by determinant of X times some other matrix. That's the formula of an inverse. When does a matrix not have inverse?
If the determinant doesn't exist?
If the determinant is 0. Determinant will always exist. Like, I'll tell you what the formula is, but if the determinant is 0, this is division by 0, right?
Yeah.
So this is the fundamental thing which we are learning today is, if the determinant of a matrix is 0, then the inverse of the matrix will not exist. So let us plug this thing back into what we are trying to solve. So if at all, we assume that it's a linear equation, we assume that all our features X's are linearly independent of each other. So let's say if I want to find what A is, I'm trying to say A is X inverse of B. But if the determinant of X is 0, then the inverse itself will not exist. So this will tell you. So the fundamental thing which we want to learn from this is, when does the determinant of X be 0? Determinant of X is 0 when X does not have all linearly independent features. It does not have linearly independent features. Linearly independent. Now you see how everything is tied together. If X does not have linearly independent features, the determinant of X is always going to be 0.
Metric help us to identify the linearly independent.
Exactly. So matrix actually helps us to identify if the matrix which you actually put in will tell you whether it has linearly, if everything is linearly dependent or not. So I think one of you asked this question. Let's say if you are in data science and they give you all these features, right? So what you will do is you will create this matrix and calculate a determinant of the matrix. If the determinant of the matrix is 0, then that means that some of these features are dependent on each other. So instead of you sitting and like plotting the graphs and stuff, instead of you actually going through the pain of seeing whether it is whether it's linearly independent or not, the mathematics will tell you whether it is linearly independent or linearly dependent. So that's why we are learning this.
Metric calculation, we must have some tool like MATLAB or something, right?
Yeah, so we are going to do that. That's why we have NumPy, right? So in case of, so this is just the basic of thing. Then I'll talk about covariance, correlation. So we have a little bit more math involved, but I think this math should be learned from a stage as to why we are learning it. So I can just teach, oh, there's a determinant of a matrix. If determinant is 0, then it is not. But you understand how, like, why each step is important, right? Because we calculated the problem as X times A equals B. And now I want to calculate what A is. If it has a solution, then it should be A equals X inverse of B. But if determinant of X is 0, then this does not have a solution. There is no solution for this. And when is determinant of X equals 0? When X does not have, when it has linearly dependent features. Determinant of a matrix is not 0 when it has linearly independent features. Now you see how everything is tied together, right? So now let us go back into our slides and see whether this is possible or not. Okay, there is another property of a matrix. If X consists of linearly independent features, the number of linearly independent features is called the rank of a matrix. So what is rank of a matrix? Rank is number of linearly independent features. So ideally, for a determinant to be non-zero, what should the rank of the matrix be? So let's say I have a matrix like this, which is M times N. N is the column and M is the number of rows. What should this rank of this matrix be for it to have a solution?
2, right?
No, it's M and N, right?
Okay.
So
M into N.
So M rows and then N is the number of columns. So I am saying number of linearly independent features. So let me explain this again. So in this case of the matrix, what are the number of features here? So let me go back to the Indian liver patients example. So basically we were creating a matrix which is like this, right? So M is the number of rows, N is the number of columns. So I am saying that for a matrix, to have an inverse, it should have, each of these features should be linearly independent of each other, right? So each of these features should not have a combination of other two, or it should not have a combination of any other feature. So what should the rank of that matrix be? And what is rank of a matrix? Okay, let me break it down. Let's say if I just take 3, let's say I take 3 columns or 3 features. And let's say if all the 3 features are independent of each other, the rank of this matrix would be what?
3, right?
3.
Exactly. So there are 3 features and the rank of the number of rows doesn't matter. Number of rows is number of observations.
So it's number of columns?
Number of columns, because each column is a feature. So when you are creating this matrix, each column is a feature. So if you have an M by N matrix where N is the number of columns, it will always have a solution when the rank of that particular matrix is N. That means that each of these features is linearly independent of each other. I'll repeat this again. So basically when we're creating this matrix, M is the number of rows, N is the number of columns, right? So all I'm saying is in order to feed data into our machine learning algorithm, each of these features should tell you something unique about that data. So you cannot have one particular column which is a linear combination of this column plus this column, right? Because this particular column should give you something unique about that particular data. So if you are actually creating a matrix where every column is independent, then the determinant of the matrix is not 0 when each of the column is independent of each other. Even if one column is dependent on each other, your determinant is going to be 0. I'll take some questions at this particular point. How many of you understood this completely, or how many of you still have confusion?
I understood, but I have one question.
Yeah.
So are we counting this data set one? If we're not, then it's an n-1.
No, what I meant by that is N is always, so this is a particular case where I'm saying, so your n-1 is my N. So N is 10 in this case. So
okay.
don't consider the data set. I've always removed the data set to be another dimension.
Okay, yeah.
So N is always 10. So, but then I want you to understand this whole concept. So why are we learning this matrix? Like, why is it that we need, and what is the rank of a matrix. I'll actually show it in the slides also, and we will calculate that for the Indian liver patients data. How many of you have questions, or how many of you did not follow anything in this? If you're not following, just ask, because it is an important concept.
So you are talking about collinearity, the independent variables and all that?
Sorry?
I mean, if so, you're telling that each of the variables, each of the columns should be independent of each other, right?
Yes.
So is that concept called collinearity?
We'll talk about that. So let's not get into collinearity is when both of them are linear together. I have another set of slides which will talk about that thing. So for now, don't go into collinearity. All I'm saying is if they're independent of each other, that means one cannot be expressed as a sum of the other two. Like,
okay.
So one column cannot, let's say you have column 1. So, oops. So let's say you have column 1, right? Column 1 cannot be expressed as some alpha times column 2 plus beta times column 3. So they both cannot be linear together. Like for example, in case of our bedrooms, right? Total square footage is basically the total square footage of the house is basically some like 5 times the square. Let me clear it. So in case of that house example, total square footage of the house was 5 times the number of bedroom times square footage of each bedroom plus square footage of living room plus some, I don't know, like square footage of bathrooms. So if I'm actually having this as a feature, then this is linearly dependent. It can be expressed as a combination of these two things. So these are not linearly independent of each other. But square footage of bedroom and square footage of bathroom, they both don't share anything in common. So they both are linearly independent of each other. So if I'm having these two as my feature sets here, square footage of bedroom and square footage of bathroom, and just only these two, the rank of this particular matrix will be 2 because each of them is linearly independent of each other. And the determinant will be not 0. Determinant will not be 0. Because if determinant not 0, there will be an inverse of this particular matrix which exists. And therefore, your A will have a solution, X inverse of B. Any questions at this particular point? This concept is very important, like how do we pick features and why exactly because sometimes when you take all these features and you train your machine learning model, sometimes the results will be really bad. And then you will be like, oh no, this model is really good, but why is it bad? It's because the number of the features which you selected are not the right set of features, because sometimes there are some features which might be which might be dependent on one another, and therefore you might have issues with your model. Is this thing clear?
Yes,
Yeah.
so it's clear. I just want to get back to how do we calculate the determinant?
Yeah. Now we'll go back to the slides. I just want to know the concept of if the concept is clear. So I'll go back to the slides again, and then we will go into that thing. So now I think the slides will be more. It'll make more sense when you just go through the slides. Let me.
So my question was like, how do we do the determinant? How do we calculate the?
Yeah. So I'll show that.
Okay.
So now I'll just show that right now. So basically we did multiplication of matrix. We know now the main thing is division of a matrix. It's not possible. Dividing one matrix by another is not possible, but matrix can be inverted and multiplied. So that's what, right? A inverse of X. So matrix can be inverted and multiplied, which is equivalent to division. Not all matrices are invertible. Before inversion, let us look at types of matrices. So there are some types of matrices. If the number of rows and columns are different, it's called rectangular matrix. If the number of rows and columns are same as square matrix. If the it's called upper triangular matrix. If the elements above the diagonal and the elements below the diagonal are kind of similar. So basically, it's called these are all just conventions. You need not worry about all that. Like this is just to know. Symmetric matrices are ones which are similar in across the diagonal, like you see 10 and 10, 15 and 15, 20 and 20. They're called symmetric matrices. Anti-symmetric matrices are just the negative of, so 5 and minus 5, 15 and minus 15, minus 20 and 20. They're called anti-symmetric matrices. It's just for notation. But then, so if you multiply a rectangular matrix with its transpose, it will always be symmetric. So you will do an example to see that. I mean, what it means is when you multiply the transpose of a matrix, like this is a matrix, you take its transpose and you multiply, it will always be symmetric. So 15, 15, 21, 21, 29, 29 and 85. So now let us go into the determinant of a matrix. So determinant of a matrix is always, it's determined by, it's actually denoted by det of A or det of this thing, or it has like 2 lines and A. So that's basically a determinant of a matrix. So the way we calculate it is like, I think you were asking, right? If you have like an element like this, this is a simple 2 by 2 matrix. If you have elements like A, B, C and D, it is A times D minus B times C. That is the formula of a determinant of a matrix. So, I mean, you can, so basically there is a function in NumPy, said det of A, it will give you the determinant directly. You need not know how it's calculated. So you have so many packages right now that you need not know, but this is the formula. But visually the determinant of a matrix, if you have like 3 particular features, it is the volume of this particular parallelogram. But if you have only 2 features, it's the area of that particular parallelogram. So if the determinant is 0, that means that both, so you can clearly see, right, if both of them are linearly dependent on each other, let's say if one line is like this, another line is basically on the same line, you have the other row, because they are a linear combination. The area which it will enclose is always 0 because it's just one line. I don't know if you can visualize that, but here I'm just saying like if you have like 2 vectors, or if they are linear combinations of each other, then one of them will be this particular line and other one will be a superimposition on that particular line. So the area between both of them will be 0. I mean, that's just to visualize. So you can actually, so this slide is, so this is the formula. So determinant of 3 by 3 matrix is different from 4 by 4 matrix and stuff. You need not worry about the formula as such, because NumPy has a function called determinant of A. You will actually directly, it will calculate that for you. So you need not worry. But what you need to know is this thing, this particular slide. If we consider each column of a matrix as a vector, the determinant is nothing but the area or volume of that parallelogram or paralleloid. If the determinant of a n by n matrix is 0, then the matrix is not representing n dimensional transformation. If the matrix column is dependent on other columns, then its determinant will be 0. So this is this is the main point. The third point is the main point. If the matrix column is dependent on other columns, then the determinant will be 0. In data science, if there are n observations and each observation should be independent of other, like feature, right? If the observations are dependent on one another, then one cannot find a solution to the problem. One can find number of linearly independent columns by the rank of a matrix. The rank is equal to the number of variables. If the rank is equal to the number of variables, then each variable is independent of each other. All of them can be considered for solving the problem. If the rank is less than the number of variables, then some of them are dependent on each other and don't add new information to the solution. I'll give you just a minute to go through these points. Let me know if any of them doesn't make sense. It's exactly the same thing which I taught initially, but this is like putting all of them as bullet points. If you understand this slide, you have like you understood the crux of like how data engineering works.
So if the rank is less than number of features, then
you should remove some features from that particular matrix.
So okay, for a good data science study, like always the rank should be equal to number of features.
Yes.
Is that what you're saying?
Yes, the rank should be number of features. For a good data science model, the rank should always be equal to the number of independent features, let's say in our case, right, we have 10 columns, right? So we will now, I think I have to teach you NumPy arrays right now, because I want you to find the rank of the Indian liver patients right now. But I think I need to teach you some stuff before you go there. So it's a fun exercise. So when you actually do that, when you find the rank of that, you will know whether the features which we are taking are linearly independent of each other or not.
I just had one question.
Sure.
So I read that you could only find the determinant of a square matrix. So like in our Indian liver patients, we wouldn't be able to find the determinant. So like in that case, how would you be able to like do any matrix like equations or?
That's a very good question. So basically, that's what I was teaching here. I mean, this is exactly. So what we do there is we actually multiply the matrix with its transform and try to find the determinant of that. So so basically you have matrix A, then you actually multiply it with its transform. So
and then is it then a square matrix?
That becomes a square matrix.
Okay.
So then you find the determinant of that.
Okay.
So I mean, that is in my next slide. I was hoping someone would ask that question. Anyway, so determinant of a matrix. So this is how there are different kinds of determinants. So for a diagonal, okay, let's just do it. For a 3x3 matrix, determinant is calculated like this. Well, wait, before that, are all the points clear here? Like, why is it that now why are we learning matrices? Why is determinant important? How is determinant related to data science? Like, what are each of these features? And why do we need inverse of a matrix? And then why is, like, for inverse of a matrix, why is determinant important? It should be clear, right, with this particular thing. So we should always choose features which have some new information. If you don't, so as a homework today, I mean, we'll try to cover, now I think the next 1.5 hours, we'll do like mainly programming. We'll try to like see how we can create different matrices, like, and how we can read the Indian liver patients data and stuff. But I want you to find I want you to find and tell me like all the features which we have in Indian liver patients, should we use them or not? How will you tell that? Like, what are the steps?
So you find the rank of the matrix?
Yeah, you find the rank of this particular matrix, and this matrix. So firstly, there's something called as data cleansing, which we will do. So for example, this one, data cleansing means that, let's say this is male and female, right? How will, like, the computer will not understand male and female. So what we'll do is we'll replace all the females with 1 and all the males with 2. So all the features have to be number formatted. So first thing we will do is like the data cleansing, and then what you will do is you'll create a matrix with these 10 features and you'll find the rank of that matrix. If the rank is equal to 10, then you can use all the features. If the rank is less than that, then there are some features in this which we need to avoid. Is that clear?
So from our perspective, how do we know like which features are independent of each other? Because like
you don't know, right? You basically will, okay, for example, let's say you didn't get 10. The rank was not 10. So what you will do is you'll take 8 of these features and then calculate that particular rank. If that rank is 8, then you will say that, oh, the other 2. So basically the rank will tell you also, right? When you do the rank of a matrix, it'll tell you 8, 7, 6. So then it'll tell you what are, like, some features are something which you need to avoid. It's just by trial and error that you will pick those things now.
Oh, okay.
So, I mean, there's no particular way, but when we do principal component analysis, this exercise also you need not do. Basically, principal component analysis will automatically pick those features for you. So I don't want to go into there right now, because at least you need to first understand this concept before we go into principal component. So ideally, right, when you ask like, how do I know, you generally take this data and you do a PCA. PCA stands for principal component analysis. That will automatically pick all the linearly independent features for you. So you need not worry about dropping some and not. But at this stage, let's just do the exercise from the basics.
So Sai, conceptually, like, I'm trying to extend the same question here. Like, So it's a subject matter, right? Like, somebody has to exactly know what feature, as you know, in housing example, we know that, okay, the square footage of a particular bedroom or a bathroom is like is key here.
Yes.
Whereas total square footage is no, it doesn't, because we all know about that subject.
Yes. So
Right.
subject matter expert will do it, but you will never always have, like, for example, right? I deal with, so one of the data sets which I have, I deal with prediction problems. So I actually get like a lot of data. I get like, oh, this person bought this items. This is his income. This is his age. This is his, like different data, right? I'm not a subject matter expert, right? How will I know which ones to pick and which ones not to pick? So in that case, what I'll do is I'll take all the data and then I'll try to find the linearly independent features. So the way I do it is I don't calculate ranks and stuff. I take the data and do something called as principal component analysis. So that particular algorithm will give me all the features which are linearly independent of each other from this data.
Okay.
So we will learn principal component analysis in the future classes, but remember the term PCA. I mean, I don't know if you're actually currently already trying to solve these problems, but the first thing you will do whenever you have a lot of data is PCA. So that will reduce the number of dimensions, and it'll PCA is the same thing as R. I don't know what RREF is. What is the full form of RREF? Reduce? No. RREF is a little different. I'll talk about the difference there, but no, it's not the same thing. There's a small difference there, but anyway, we will cover that when we cover PCA. We will. No worries. His mic is not working. So yeah, when we'll cover PCA, I'll cover a little bit on that. But let's not go into PCA because it's too much math for a day. But I think I hope this is pretty clear as to like why the determinant and this thing is done. So inverse of a matrix. So here, since a rectangular matrix is, I think this was the question Meher was asking. Since a rectangular matrix is not inversible, so we need to find 10 variables so we can multiply both of them so that it will become this thing. So when we multiply both sides, so here what we do is, Meher, in this case, we just take 10 features, or you can actually multiply it by transpose and then take the inverse of it, because it's you just take 10 observations, right? You want to, because rows are in your hands. You can actually pick any 10 rows and then make it a square matrix and do that, or you can actually do a transpose of it and then multiply it. So generally, inverse of a matrix is a very complicated operation. So that's why generally people do PCA. Like if you have like 5,000 features, inverse of a matrix will take up to like 8 hours to calculate. So generally, that's why people don't do rank and stuff like that. They directly apply PCA on the problem. But since our case, we only have 10 observations, we will start by doing PCA and stuff like that. So geometrical interpretation of a matrix. So this is the beginning slide for PCA, but I won't cover PCA today because now like you have all the data, right? Now main thing we have to cover is programming. Like how do you actually write these things? So let us actually get the console, like your PyCharm out. So is this thing clear? The theory wise, this is clear, right?
Yeah.
Okay. So let us let's start. How do we actually read this data? Let's see how do we read this data and stuff. So let's open PyCharm. Let me so now we go back to NumPy. So basically this thing I covered last time. So let's do some basic exercises, right? So okay, I'll give you the same thing from here. First and foremost, create two matrices and add them. So how do you create a matrix? So matrix is nothing but you create them by giving two arrays. So you say np dot. So matrix, you don't have anything. So let's do this. You create two matrices and add them. Let me look at. visualization. So let's do one example in which you add both of them. Where did it go? Yeah. Look, can everyone see my screen here? So
Yeah, we can.
yeah, so what you will do first is you will create a new I think in one project you guys have installed NumPy as a package, right? So in that, create a new file called NumPy basics or something. So I actually created something called as NumPy array basics. So you again, like, you create a file by right clicking and saying add Python file.
Can you show us how to add the package again?
How to add the package? Sure. Yeah. So basically, you have your project. You go file, settings. In settings, you will have something called as project one, but go and click the project interpreter. So you'll have, when you open the settings, you will see this. It won't show you the current project which you have, but it will show you the first project you've added, because you added everything into the same project, right? So you will first go and click project session one, and you'll click on project interpreter. In project interpreter, you will see all your projects here. So I don't know which session you're using. If you want to create a new project, create a new project, call it session 3. And when you click on this thing, you will see this plus sign here. For Mac users, you will see it down here, but for like Windows users, you'll see the plus sign here. You go to the plus sign, and then I asked you to install 4 packages: NumPy, Matplotlib, Seaborn, and Pandas. So today we will do the next 1.5 hours. We'll just do how do we call these things, how do we load these things, how do we multiply, and stuff like that. So you go and type NumPy here. You'll see NumPy, and you'll click install package. So let's quickly open. If you have already installed it on one of your, projects, then just add a new file called NumPy basics. Because today I want to cover, if possible, cover visualizations also. So first thing is you need to import the package. So you say import NumPy as NP, because NP is what you will use later on. So let's not go into, I'll send you my code later, but let's just do the code which is there in the presentation. So what you will do is you'll create 2 matrices. How do you create a matrix? You will say np.array, and then you will give 2 square braces. So all matrix is series of arrays, right? So for example, in this case, 3, 5, and 7 is one array, 0, -1, and 6 is another array. So you see here, this particular line, it basically, you create 2 arrays and you add them into your this thing. So you create one array, say np.array, you create this array, and then np.array, you create the next array, and then you add both of them and print C. So this is just to get you started on NumPy. So it won't be this simple to create arrays and stuff, especially once you read the Indian liver patients data and stuff like that. It will be like reading from a CSV and stuff. I'll teach you how to do that. But just to get you started, NumPy arrays. So let's just, so we have to learn NumPy arrays to create matrices, because matrix is a set of, each row in the matrix is again an array. So I want you guys to like write this code at least for. So you have to write this, and then you will do like transpose of a matrix, and you will do determinant of a matrix. So before we go into the next portion, we'll finish these things right now. Let me know if you have any more questions on.
Last week, the problem which happened with import NumPy as NP. It's still continuing, right?
So can you actually like create a new project with install everything freshly?
Okay.
Because I am not really sure why it is happening, because it's either you have a corrupted cache or something, or if the problem really persists, just reinstall PyCharm.
Okay.
In case if it doesn't get solved, because that's not something which is normal. It should work for most of the people. So what we'll do is we'll create these things, and So I'll wait for all of you to finish. But now you understand why matrices are useful, why determinant of a matrix is. Because when we were studying as a kid, it was just like, oh, okay, determinant means this is this. But there was never a real world example to understand why inverse of a matrix does not exist or how it is relevant. I hope like this example will make it clear for you, like, oh, what linear dependence is, what linear independence is.
For now, can I only install NumPy or do I have to install all 4 of them?
We'll just install NumPy for now.
Yeah, okay.
Because did all of you get the data sets I sent you? I think I sent you like one text file with some snowfall information and other is like video game results.
Yeah, we got it.
You got that? Because I want to spend this class and next on just visualizations. They're like really beautiful graphs which you can draw and you will see. Like the video game sales, I'll just show you the one which, and I'll tell you which graph is useful for what also. So we are still not getting into the crux of machine learning algorithms as such, because we need to spend time in actually understanding, these things first. So we will first finish off on data clean. Do you want to see the presentation? Like, you know what you have to create, or? Because today I thought we can do like box plots and stuff like that. So let's see. Once this is done, we will continue further. So all you have to write is this program: create 2 matrices. The way we create matrices is basically, mind you, the 2 square brackets. The reason is because first square bracket will give you first row, another square bracket will give you next row, and then the surrounding square brackets will tell you that both of them are a matrix, like both the arrays are into one matrix.
Okay, now it worked.
Okay.
Yeah.
And then you print it. So after we do that, what we will do is we'll create, let's not do matrix multiplication. I think the main thing which you have to learn is determinant of a matrix, right? So I think that one will be, yeah, it's called det of determinant of this thing. So maybe I'll give you some as a homework. Anyway, is everyone done with this? Did you guys create 2 matrices and add it?
Yeah.
Okay. Does anyone need some more time?
Just like 1 minute.
Sure. I'll send this code also, so you need not worry. So I'll send how. So basically, here's the thing: I created 2 matrices, A and B. Just know the syntax of it. The way I do it is by using 2 arrays, and then transpose of a matrix. We do A dot transpose. It'll give you transpose, so you can print it out. I can print it out. So you'll see that the transpose of a matrix which is print out is just swap the rows and columns together. And then there are some basic things of like matrix multiplication and stuff, but that I don't think, I don't think we need to. It's good to know. I mean, anyway, as a homework, you will actually run each of these things. So you'll keep this file as a reference so that you can, run these things at home. But the main thing which I wanted to show was 2 things. So everyone understands why the dot product is important. If the dot product is 0, that means that the angle between both of them is 90 degrees. So that's why we do like the dot product stuff. There is one more parameter in when you're creating a numpy array is when you do np.array, you give this thing, you can actually say you want it as float or int or stuff like that. That is given by something called as d type. So when you actually create an array, right, like you do a equals np.array, and then you create, let's say you create 1, 2, 3. And if I want to specify that these are float values, then I can say that d type equal to, then you can give it like in this case, I want to do it like float 64. Float 64. So then it'll consider everything as a float type. So that's one way you can create this thing. Oh, sorry, it's np.float. So np has float types and stuff like that. So printing of a matrix, but the main thing I think which you will be interested is this particular function. Why don't we create let's do this. If you're done with that, create a square matrix and find its determinant. Is that clear what we want to do?
Yeah, I'm done with that.
Or you've done the determinant?
Yeah.
The other thing is also then find the rank of a matrix. So the main things which we will do is finding the rank of a matrix and finding the determinant. The way we do determinant is called by saying dot det is the function. I'm just trying to look where I've done that. Matrix multiplication and we add it somewhere. Dot shape. I have to, but the function for like a determinant is basically np.det. So you will actually, you can just use the determinant of a matrix to find. So create a square matrix. A square matrix means the rows and columns should be the same, and then you will find the determinant of that matrix. In case of Indian liver patients, you will just give .det. Transpose is .transpose. So is everyone done with that? Like, how do you find a determinant of a matrix? Or maybe I can just write the program. So this is a square matrix, and then I just say transpose of A equal to A dot. That's how you find the transpose, and then so this is how you find the transpose, determinant of the matrix. So NP has another package called linear algorithm. Linear algebra. So np.linear algebra package dot determinant of A. So you can store this as a value. So you can actually, one fun thing you can do is you can actually create something. You can create your own linearly dependent features. How will you create that? Your each row or each column should be, let's say if it is 1, 2, and 3, you will make it a combination, right? So you'll make the other column as 2 times of that thing. So you'll make it 2, 4, and 8. So they both have linear dependence. And when you try to do determinant, it will give you an error. You can create your own linear independence and then calculate determinants. Is that clear? Are you guys still working through the determinants and stuff? Or can I go further? Because we have to cover, next we have to cover pandas, and because once we cover pandas, that's when you can actually start importing the data.
So transpose is a already existing function, right?
Yeah, dot transpose, like a dot transpose, you will get transpose. And for determinant, you will first take the NP package, and so I told you, like, packages have sub packages in them. Packages have functions, and they have something called as sub packages. So NP has something called as linear algebra package. So you can actually get the linear algebra package and then take the determinant of that. Then you will get the determinant. So if the determinant is 0, so I think as a homework, take this down as a homework. So create a linearly dependent rows for your matrices, and then try to find its determinant. You will find that the determinant is it will say the determinant is 0 for that particular thing. So that's a little bit intro into this thing, but there are a lot of things in so I'll cover some time on NumPy. We'll do, I mean, I won't ask you to do all the programs right now. I'll do some programs. Wait, is there anyone having issues with finding determinants and like transposes and addition of matrices?
I was just wondering, how would you, because you were saying to make linearly dependent matrix, like how would you do that?
So you would basically create so your columns, right? So if you see here, it is 1, 2, 3, 4.
Yeah.
Right, but your column is 1, 5, and 9.
Yeah.
So, and the second column is 2, 6, and 10. So instead of giving 3, 5, and 3, 7, and 11, what you do is you just add these two and make that your third column.
Oh, okay.
So now 1 plus 2, 3, 5 plus 6 is 11, 9 plus 10 is 19. So now the third column is a linear dependence on these two, because it's add these two, you get this.
Okay.
So now, and then find the rank of that matrix also.
Is there a function to do rank with?
Yeah, rank of a matrix is np.rank. So there are a lot of functions, like I won't be able to cover all of them, but most of them you should if you look at the NumPy documentation, you will find where is the rank? Where dot product? Yeah, it's called np.rank.
I used np.rank for one of the assignment questions, and the compiler told me, the system told me that use np.linalg and matrix underscore rank. So that's okay.
Yeah, you can use so I think linalg also has the rank of a matrix, so you can use the function from there. But anyways, like these are the three main concepts of how you create NumPy arrays. So remember, I was telling you, right, if you want to do arrays, we'll use NumPy in Python, you just generally use lists. You don't use arrays, but because NumPy has so many array operations. The main reason we will learn arrays is because you have to create matrices. For matrices, we will start from like NumPy arrays and stuff like that. So having done that, I'll just go through the basics of like what NumPy does. So it is mainly a core library in Python. It's used for matrices, matrix operations, arrays, and stuff like that. So here is the thing. So basically, so this has rank 1 because it has only one row, right? So it has only rank 1. But if you have 2 rows which are independent, it will say rank 2. And indexing is similar to how we, I think I covered this last time, but it's similar to how we do it in like strings. You basically give 2 to 4, it'll give you 2 and 3. The last 4 is exclusive. And then you can do -1, which will give you like the reverse of that thing. So that is like the basics of arrays. You can also do different like multiple indexing. So you can print out, A of like for example, you can instead of giving like instead of giving 0, 0, 0, 1, 1, and 2, 2, what you can give is you can directly print out 0, 1, 2, and 0, 1, 1. So all I'm doing is I'm putting this particular each each row in one array and each column in another array. Like 0, 1, and 2 is one particular row, and 0, 1, and 0 is another particular column. So I'm putting, so you can do multi-level indexing and stuff. So this is just to get you familiar with NumPy arrays. So we won't be using as much, but in some cases when you want to, like, add access of one particular specific element and stuff, we'll probably use these things. So we have seen what matrices are. So we've like dot product of a matrix. So we have like basic things like addition, subtraction, division. Obviously is not exactly division. You take the inverse of it and multiply it. But these are the functions. Like if you want to take the dot product of two things, you just say v dot w, or you can do np dot. So np has like this package or like this function which actually will take dot products of two particular matrices or two particular vectors. So I have this code here, so you can try it out later on. Like it's both in terms of the presentation and the code. I'll send you my code so you will have a look at like how to do it. So other thing is you can have sorting functions. So you do np.sort, you will actually sort that particular array. Then there are like polyfit and stuff. I mean, I just want to like list out some functions it has. So that's the main thing about. So is everyone like okay with NumPy arrays? Like then we will go into pandas. Any questions on NumPy arrays? So you can explore the packages. Like they have like a lot of things like inverse, like multiplications, and then there is a polyfit. Polyfit means it'll fit a polynomial to the array you send. So remember, like if I was giving you some data, right, for x and y, and telling you let's fit a line. So it'll do that automatically for you. It'll take care of the math behind how you fit the line between them, and it'll give you that. So there are different functions which you can play around with, but basically how you call them is the syntax and everything you need to learn. So everyone okay with NumPy? Do you guys want to spend some more time with NumPy, or should we go with pandas?
I think we're okay with NumPy.
Yeah, NumPy is pretty basic. Like it's just like arrays and stuff. The main thing, in fact, we won't be using that much also. Mainly the reason we will use NumPy is for learning pandas. So pandas is like the most important package for data processing. So if everyone is clear with NumPy, we'll go ahead with pandas, because so I remember I asked you to install pandas package also, right? So the difference between NumPy and pandas is NumPy is just for creating matrices and stuff, but pandas actually has some default data structures. So whenever you want to read the entire CSV into, like for example, in this liver patient data set is there, right? So you want to read the entire file into a particular matrix, you will use pandas. So pandas is the mostly used data structures package for data science. So let us just look at what pandas does. So firstly, pandas is easy to use data structures, and it has data analysis tools for Python.
Can you tell again how to install panda?
How to install? Just so in your same package, so you go here and then click on settings, and then you hit your project interpreter, right? So whichever session you're using, click on that and hit plus, and you'll just type pandas, PANDS, DAS. You'll see pandas here, and you click on that and say install package. So that you will install the pandas package like that. Is that clear? So the main reason we actually use pandas is for something called as a data frame object in pandas. We will spend some time coding that. So first thing I would like, once I teach you pandas, I would want you to do is to read the whole Indian liver patient CSV exam, this thing into a pandas data frame. The reason, like that's how all data processing works, because pandas provides you these inbuilt data structures, which basically help you with processing of these large data sets. So they have tools for loading data into memory, and they can load from directly from different file formats and stuff. And also if there are any missing values and stuff, so pandas provides like a lot of inherent functions with which you can replace the missing values. You can replace the not a number values and stuff like that. I think rather than the slides, the best way to learn this is just by programming. So let's start with that. But before we start pandas, there are three main data structures in pandas. So first one is called series. Second is data frames and panels. We won't be dealing panels because panels is three-dimensional structures. Unless and until you are doing 3D computations, like, you know, where you have like X, Y, and Z axes, and like you have like 3D computations, we won't use panels much. Most of the time we'll use data frames. So this is like the most, because okay, firstly, what is series? Series is one-dimensional homogeneous data. Now, what does that mean, right? So that means that you just have data which is like in case, like if you take this thing, this is two-dimensional. Two-dimensional meaning you have rows, you have columns. But let's say if I don't have additional rows and I only have like one row, which has like different numbers here, then you will use series. So series is used for one-dimensional. One-dimensional meaning there are no rows and columns. There's just one row with multiple columns. Let's say you have one data. Best example for a series is stock price of, let's say, a stock price of Amazon, right? So the price is basically one value, which will keep changing every hour. So if I want to store that, particular value, I'll store it into series. So like in first hour the price is 1800, second hour the price is 1850, third hour the price is 1900, then 1950. So it doesn't have different different metrics. It's just one dimensional. So there is only one metric which keeps on repeating. So that's when you use series. But when will you use data frames? Data frames is used for so data frames is used for when you have like different rows and columns. So most of our structures or what we read are data frames. So it has the ability to store different columns and different rows. Let's say we have 512 observations, 14 observations, and 10 columns, right? So we can read the whole CSV file into a data frame. A data frame has both like number of rows and number of columns. When you don't have like two things and you have only one category, you will use series, and other category you will use data frames. So let us instead of looking at the slides, let's start coding. Like let's just can you guys still hear me?
I can hear you.
Yeah, you can. Okay, let's start with the fresh this thing. So in the same project, create another file called pandas basics. So the way we create it is like, because look at the project in which you have installed pandas. So let's say if it is session 2 only, like you then right click and say new Python file, and then name it as pandas basics. So is it clear why do we need pandas? Because in general, just to operate on matrices and arrays and stuff, we use NumPy and other functions like determinants and stuff like that. But when you want to read the large chunks of data files and you want to store them into one data structure, we use pandas. So pandas is like the most important data structure which we will use. I mean, we'll be using it always. So we'll spend some time creating like loading pandas and stuff. So the way we import pandas is similar to how we forget about Seaborn and this thing for now. Let's just load pandas. The way we do it is import pandas as PD. And remember how I told you can create a series. So let's just first create one particular panda series. Then we will do data frames. Everyone understand the difference between series and data frame? So series is when you have only one dimensional data. For example, in this case, I'm creating panda series by saying pd.series, and then I pass in one dimensional data. That dimensional data is A, B, C, D. So, like I have like 4 things of the same, like as one array. So I create it with an array, and then I can give indices to it. Instead of having, if I don't give index, it will be taken as 0, 1, 2, 3, 4. But if I specifically pass it an index, it will take 100, 101, 102. So let's just print this and show you how it is. So when I run pandas basics, I think yeah, we will not do this first. Let us finish. First, let's just do series. So you see this here, the first. So I created a series which is basically having values A, B, C, D, and I'm given it my own index, which is 100, 101, 102, and 103. Let's all create a series first. So the way we create a series is, you can create a series from an array, right? Because a series is just one-dimensional data. So if something is changing every day, then we will actually just use a series for that. Because you don't need columns and rows, right? So you can just create like this, and you can give your own indexes. So let's just, so create a numpy array with, no need to use these letters, but create a numpy array, let's say of the stock price. And let's give 5 days stock price. Pick a stock. Let's say you take Microsoft stock, right? So what you have to do is create first an array, which is MSFD, and then you say that np dot array, and in this you can actually give the stock price of Microsoft as as it was for the last 5 days, say 114.2, 114.5. Then we have like, just give 5 days stock price, and you can actually give your whatever index you want. The index is the day. Let's say today, let's say it is like the 240th day. So then what you will do is, once you create this particular array, you'll create the pandas series. You say pd.series, and in this, since you've already created this array, you will pass in your array, and then you will say index equals whatever index you want it to be, like 240, 241. So this is the day, like 240th day of the year, 241st day of the year, and 242nd day of the year. And then and then print out the series. Is this thing clear? What we're trying to do here, we're just trying to create a series in pandas. So pandas has 3 main things: series, data frames, and panels. Panels we are not looking at because that's for 3-dimensional, like if you have 3D modeling and stuff, we'll use panels, but most of the stuff is 2-dimensional, right? Because we have rows and columns. So either we read them into a data frame, or if you have one single row, like case of stock predictions and stuff, we will use only series. So what we are doing right now is just creating a pandas series.
I'm not getting that import recognized.
Do you have pandas installed?
Yeah, I just installed it.
Does it is the spelling correct? Import pandas as PD?
So I think the problem is there's panda and pandas.
Oh, so
yeah, so there's one called panda. That's what happened to me last time. I installed panda instead of pandas.
Oh, so the package is called PANDAS, pandas, not single panda. So I think when you're installing, please install it. Oh, thanks. I didn't know that there's a panda also. So please install PANDAS.
Can you tell me again that?
It's PAN.
Yeah, that I know, but
Yes.
the same process, how to
Oh,
install.
the process. Okay. So you first, I mean, need not, like, let's say you've created like session 2 or session 3, right? You go
Yeah.
to file, settings,
Yeah. Okay, got it.
and then you have to click on project interpreter,
Okay, and then add pandas, right?
and then click on session 2 or session 3. Click the plus sign and then type in the full name, PANDAS. PAN. So you will see the word pandas here. You click that and say install package.
Okay. Let's see. Yeah, installing it, I think. So does it matter if we install in different area,
What do you mean different area?
like session 1 instead of session 2 or something?
Yeah, because you remember how each of them has its own virtual environment, right? So session 1 is basically it's your first project. It has a different virtual environment. Session 2 has different virtual. That's the whole reason we did virtual environments initially, because virtual environments are specific to one particular project. So let's say if your session 2 virtual environment gets corrupted, it shouldn't affect your session 1. So you have to install in whichever project you are using, you should install it there, because that particular virtual environment should contain this package.
Oh, okay. Yeah, it's installed. Just a minute.
Sure. How about others? Like, are you installing it?
Yeah, it works.
Okay, so let's just first start with Pandas series. So we'll just create a basic thing. So you know what? Like, so basically, why series, right? Series is if when you have one-dimensional data, like the stock price or only one thing. But when you have like multiple frames, like multiple like rows and columns, we will read it into a data frame. So right now we are just doing Pandas series, a simple. The different, just the first data structure in Pandas. All we'll do is just series and data frames, and after that, I think we should be done. We won't be that, and we'll do some basic plotting, and after that, we are done with Python. We won't be learning a lot more into that. But if you understand these data structures really well, then I think for data science you don't need more than this much. So create a particular Pandas series, like for example that of the stock price of one particular company, and then just output, give it the index of the day, like 240th day, 241st day, 242nd day, and print out the series. Let me know once everyone has just finished this thing, because there are other things you can manipulate in the series. So it's similar to an array, but they provide additional functionalities. Like you can add new in the middle of the array, you can add new elements, you can delete new elements, and stuff like that. So we'll do some basic pandas programming today. So we need pandas and NumPy for when we start data visualization and data cleansing. Let me know when you can print out this series. So what you're doing now is just creating the first data structure in pandas, which is the series. Again, when do we use series? When you have like one-dimensional data. So when you're done, let me know, okay?
I'm done with it.
Okay. So I'm hoping everyone else also is finished. Should be pretty, I mean, the only thing is basically creating, just knowing the syntax of how to create the series. So if you're done with it, I'll go through like the other things which you can do with the series. Like for example, right here, I've created indices. So now I can change the indices also. So I can actually give indices in the, the key value pair, we can create a dictionary. So since this is nothing but a dictionary, right? It's saying index and value. So you can create a series from either an NP array, or you can create it from a dictionary also. Because in dictionary, this is the key and this is the value. This is the key and this is the value. This is the key and this is the value. So all I'll say is like I can create a dictionary and I'll say pd.series with the data. And here index doesn't make sense because I already provided the indices here. But the thing is I can change the index as I want. Like instead of giving A, B, and C, I'll say, hey, make B first, C next, D and E and A. So is there something wrong with these two lines? Do you see something different, or basically there's something?
There's more indexes than there is data points.
Exactly. So you see that I've created only A, B, and C, but here in the indices I've given B, C, D, and A. So now you can do that in series in Panda series. So you have more indices. So when you do that, you'll see that it is actually not a number. So see the output here. So first and foremost, you can change the indices as you want. If I don't give this index, it will directly make it A, B, and C. But if I give indices, which is like B, C, D, and A, if it doesn't find a value for this thing, it will incorporate it in the series, but it will say not a number because I did not specify the value. Is this thing clear?
Yeah.
So first case, I've created the Panda series with an array, and I provided explicitly the indices of that particular series. But if you actually look at it, this looks like a key value pair. So if you have key value pairs, what is the data structure which we read last time, which is a dictionary? So I created a dictionary with key value pairs. But the advantage of this is I can add more indices which is not part of the data, and then those indices will be populated with not a number. So we can do that. And then you can actually, if the same value is supposed to be there for all indices, you can just give the value 5 and say index 1, 2, 3, 4. So then all the values will be of that particular index. You can also create, so that is basically series. Is this thing clear with series? So there are two ways you can create the series. One is you can do with the array, and then you can do it with a dictionary. So, and then you can also like repeat its values by giving the same indices. So series is, again, it is good to know, but we won't be even using series that much. The main thing which we'll be using is data frame. So all of you create a data. So again, data frame has 2D data, right? So it has like rows and columns. So here is a sample of how I created a data frame. So I created an object called data, and I put in like the name and age of like 3 people. So John and his age, Snow and his age, Timothy and his age. And then I populated that into a data frame. So data frame also takes in data, which is 2-dimensional, right? John and this thing. The advantage of data frame is I can give columns. So I can say that, okay, these are 2 values, but I can give column names. So this is name and age. So here is John and here is this thing. So now when you print the data frame, it will give you name and age of those two people. So you can see that here. So when I created the data frame, so it has name and age, and then it has like index. So if I don't provide indices, it will give, by default, it will give 0, 1, 2. So let's create a data frame. So wait, is pandas clear as to why we are using pandas and why we need data frames? So I know it's a new data structure. It might take some time to be used to, but even if you don't follow series and stuff, data frame is the fundamental thing which we need to follow, because all our case studies will be data frames. So if you, for example, just to show the Indian liver patients, right? The way we read it, there is a pandas.read CSV, and then you give it to the CSV file, it will read the whole thing into a data frame. So it's very important that we spend some time with data frames, because afterwards we'll be using the data frame. This is an example of how we'll get the male patients with the disease. So we're going to use the data frame quite a bit. So we'll use the data frame with the column names and stuff. So let's do the basics of like data frames. So let's quickly write a small data frame and see how we can read into it. So create a data frame which has the name and age of 3 people, and give it or instead of name and age, and give it 2 column and give the data column names name and age. In fact, do it with 3 people. So instead of having like John Snow, I'll also give it profession.
Do we have to download that Matlab package also?
Matlab is not right now. So Matlab is only for visualization. So right now we are just doing pandas. So we will be covering all the 4 packages, but right now we are just doing pandas. So today, the rest of the class, we'll just do pandas. So you don't need to do matplotlib and everything else. But then we have to be comfortable with like how we can call pandas. The advantage of, so I think, let me just do this. So why do we need this data frame, right? So clear all drawings. So you have all this data in your CSV file, right? You have column names, which is age, like you have age, gender, everything. So it would be really nice if one data structure can hold all this information together. So when we read this particular CSV data into a data frame, pandas data frame, so it will contain the exact same structure as what we have seen. Let's see if you don't use data frame, what we have to do. We have to read each column into an array and then store it and this thing. So now pandas data frame will actually contain the whole thing. It will have columns, column names, name, age, like bilirubin count, label. So these are the column names, and then they'll have the values. So that is the reason we read the whole structure into a data frame. And all I'm asking right now is to create one portion of it, just name, age, and maybe you can create a title. So let us go back to, so here is how I'm creating. Forget about, so this is the part I'm doing right now. So I'm saying that I'm creating a data with 3 column names. So John, his age is 30, and I'll say he's an actor. And then I'll create Snow. I'll create, he's a software developer. Timothy is a doctor. So I've created 3. So all I did here is I've created 3 entries. So remember, all these 3 have the same columns, right? Name, age, and profession. So these are like 3 observations which I created right now. And the way, and I'll read it into, I'll give the data into the data frame, and I'll give it exclusive column names. So name, age, and then the other one is profession. So when I print out this particular data frame, let me just print it out. Sorry, I put a lot of programs into one, so it'll run everything. So just bear with me. You don't need all this right now. But we will be going into plotting and stuff like that. So let's see where it is. Here. So if you see this section here, it made name, age, and profession. So that is the data frame which it created. Now, if I want to print out only, the names of people, I'll just say df of name. So I'll only print out the names. So I'll just say print df of name. So why don't you guys do this? To create this thing and print out the whole data frame, you will get something like this, and then print their name and their profession together. How will you do that? So you created column names like this, right? The way you print out name and columns is basically by giving df and then df of profession.
Anna, I have a quick question.
Yeah.
Here in this example, as the data you gave is just a normal list, but can we provide the data to be inside of a NumPy array as well?
Yes, you can create it from a NumPy array, but then the way you create the NumPy array is a little tricky, right? Then you will say John, Snow, and Timothy and one array, and then you'll create 30, 42, and 33 in another array, and actor, SD, and doctor in another.
So you need to have inside of that NumPy array, you need to have 3 different lists that correspond to name, age, and profession.
Yes, that's right.
Okay.
So then you can create. So the idea is basically, so you have to create a data frame ultimately which will hold this particular, all these things in the exact same format. You need to have something which says column names. You need to have something which has indices. So these are all, like, you can see that everything is of different format, right? This is a string, this is a float, this is this thing. So data frame is the only data structure which can hold all these things in different formats and have column names for it. So that in the future, when we actually, remember how I plotted bilirubin count and alkaline phosphate? So this scatter plot, which I was showing you guys, right? How do, like, I think last class I was showing you, like, if you look at the bilirubin count and with males with disease and males without disease, we actually saw how this can be plotted, right? So this is as simple as just putting one column name. So once you read it, all I'll say is plt.scatter. I'll just give the column name. So it'll give it'll take all the values in that particular column. So it's very easy. Once you're comfortable with pandas, it's very easy to, like, print out something, fill in something, and a lot of other things. So that's why let's just do this. So let's create this thing and print out the whole panda frame, and then print out their name and profession. Let me know once you're done. Any questions so far? Or let me ask this thing, is this thing confusing, or, like, how many of you are having trouble following pandas? Trust me, these are the only 2 data structures which we'll learn in Python. So once you get comfortable with pandas and NumPy, we won't be going, as I said, right? Like, matplotlib and seaborn are just for visualization. That's for the graphing library and stuff. But we'll just be using these 2 data structures for handling all our machine learning algorithms and stuff. Is anyone having difficulty following what pandas is, or why do we need the data frames, or why do we need series and stuff? So I'm assuming everyone.
Sorry, like 1 second. I'm actually getting errors. Like, I'm trying to solve it myself. Like, so the way I
you can
import.
share your screen. I can help you, because I think everyone else is still doing this, right? So if you share your screen, then we can. Do you want to do that? So the first step, what you need to do is import pandas. So first step is this. You'll say import pandas and you can give whatever name you want. Instead of typing pandas every single time, I'll say import pandas as PD. That's pandas shortcut. So after you create that, all I'm doing is creating pd.data frame, and that is taking in the data, and then I'm giving column names to it. The data consists of 3 rows. Consists of 3 observations, but each observation is basically a list of 3 things together.
For me, this name and profession are printing separately. They're not printing next to each other.
So when you do it like this?
Yeah.
Okay. So maybe you're right. I didn't run it right, so I don't know. Maybe it'll print like that for me also. Yeah, you're right. It is printing like that for me also. So you can actually use print format then.
Yeah, format I think.
Yeah,
I'll try that.
You know the format which you did, print dot format and stuff. So you can use.
Yeah, I'll try that.
So it says like I'm unable to share because it's probably.
No, because I have to stop sharing. Or you want to share?
Oh yeah, I mean you want to.
Go ahead, share.
Yeah.
Yeah.
Yeah. So I mean, I'm trying to run this.
Okay, you're creating a series, right?
Yeah. Simple series. Okay. So MSSP. It says like invalid syntax, but I mean. Is this a column?
You should give space, I think. Just give space.
Yeah.
Remove? No, so basically, so here you're creating a NumPy. So this is not an array, right? You're creating, so what you're creating is a key value pair. So NumPy array will only consist of one format. So when you're doing a key value pair, you have to create a dictionary, right? So that should actually have NumPy array is fine. You can, if you're creating an array, then it should just have the 94, 95, 96, that thing. But then if you want to create it from a dictionary, instead of saying NumPy array, you can just use the curly braces. Remember how we created dictionary last time?
Yeah. I have to create dictionary and then okay.
Yeah.
So this should work, right?
Yeah, now this should work. So, but here you should give the MSSP, right? Like here.
Instead of.
Yeah. So now run this. Pandas has no attribute called seeds. S capital.
Oh, is it?
Let's try that. Thought I had.
Do we have?
Yeah.
Yeah.
Yes. Now run it.
So this is like case sensitive.
Yeah, this is case sensitive. It has okay, now you have a different error. The value of length passed is 5, but the index implies 4. So you have how many of them? 1, 2, 3, 4, 5, and you have 4 indices. So you can exceed your index, but you cannot have less indices. So you have 4 indices and 5 values.
Actually, even if we exceed the index also, we're getting the similar error. Probably it will not work only for dictionaries is what I thought.
Oh yeah, because dictionary is a key value pair, right? So now just give 4 of them. So just remove your 106 because you have 1, 2, 3, 4, 5 and you have 1, 2, 3, 4, 5, 6. Now it should work. See, now you actually have this thing.
Okay.
So when you want to create a dictionary, then you can actually add more things. So yeah, so is this clear?
Okay, I think so. Next case, I'll try doing dictionary.
Yeah, you can create a dictionary. So don't worry if you're not able to finish this right now. I'm going to send my whole code so you can then sit and you can practice that. But right now, just go ahead with the data frames because series we want just for introduction to tell you, like in the future if you're doing like time series forecasting or something, then you can use pandas series. But then most of the time we'll use data frames because most of our data is in terms of like you have observations, columns and stuff, right? So we'll be using data frames most of the time.
Okay. All right. I have to stop sharing.
Yeah, stop sharing so I can start sharing mine. How about others? Like, are you guys able to code this thing or?
I'm still getting the same thing, as in like I used formatting and all, but it's still printing in different lines. I tried even the for loop.
Oh, okay, so let's take that offline because
yeah,
that we'll see how we can do that. But then the thing is, right, like if you generally, so the idea is basically when you do df name, it'll get all the names. So let's say if I want to plot, right, the next thing which we'll learn is plotting. So if I want to plot name versus profession or like, you know, like bilirubin count versus this thing, all I'll give is instead of accessing each one individual, I'll just give the column name. So df of bilirubin count and df dot alkaline phosphate count. Is that clear?
Yes, I can.
Okay. So one thing here is like in this case, but what about others? I don't, Shaker and all, are you guys running it?
Yeah, I'm good, Sai.
You good? Okay. Cool. So basically here we have seen that if we didn't give, so these are just column names, right? If we didn't give the index, it's giving it as 0, 1, 2, 3. I mean 0, 1, 2. So you can, the next example I have here is I'm just building on it. I just have, so I think Meher, you were asking, right? If you want to just give everything in one, you can just give it like name equals this, age equals this thing.
Yeah.
Yeah. The other thing is you can give index also. Like index, you can give like rank 1, rank 2, rank 3. Now if I print that, it will look like this. So instead of having like 0, 1, 2, it will have rank 1, rank 2, rank 2. So you can basically add indices for data frames and stuff. So one other cool thing is you can actually create a data frame from series also, because each series is one column, right? Or one observation. Right? So I created one series with 1, 2, 3, another series with 1, 2, 3, 4. And then I can create a data frame from series also. And then this is like the cool thing. Once you actually have that, you can just print out one column name. So if you want, like in this case, I wanted to print out all the names and professions, right? I just say df of like the way, same way we do key value pairs, right? We just give the column name here, df of column name, and that will basically print out all the column names in this. There are a lot of other things you can, the cool thing is you can actually add 2 columns also. So what that means is like now I've created 2 columns, df of 1 and 2, and I'm creating a new column name df of 3, and I give the new series. I can create a new column name saying 4, and I can add these 2 column names into that. So that will look like this. So once you print that out, so you see there is 1, 2, and 4. You can add like 2 and 3. I added into 4. So 1 plus 10 is 11. So it will add it into 4. So there are like a lot of cool things you can do about because all of them are, mind you, these are all floats, right? So that's why you can add and subtract and stuff like that. you can delete one column. Let's say if I don't want bilirubin count, I'll just say from this data frame, just delete this particular column name. So it'll just delete that particular column. So that's why data frames are very useful. So you can add 2 data frames also. Let's say there is one data frame which actually has the blood reports of the patients. Other data frame has like some other reports, right? Like the blood reports is one, and let's say the other one has like liver reports. You read both of them into 2 data frames, and then you add both of them into one. So you can add 2 things together. And then you can, now this is the thing, this is the most fun part, you can directly read a CSV file into the data frame. So there's the function called pd.readCSV. And then if the CSV has column names, it is fine. If not, you can give column names at the time of reading also. So in our case, we already have column names, right? So it will treat the first row as columns. It will know that age, gender, and this thing is there. So when I just give like pd.readCSV, it will read the whole thing. You need not specifically give the names. So in this case, I have a function, I have a CSV called series.csv. Look at it. So this series.csv, I don't have column names in it. So it just has data. What it has is it has date, time, and it has the value. So this is actually one of our so it just has like, you know, date, like the date, time of whatever, and then it has some value, some random value. So at the time of reading, I know that there is no first column which actually has the names of column. So at the time of reading here, I actually specified names. I said, hey, names is date and values. So it will automatically read them as the data frame. But there are like 2 cool functions with data frame is like fill NA. So remember when I added a new column, let's say if I add a new column and don't specify the values, it will take them as NaN, means not a number. So even in the previous one, in the dictionary example, I added a new index. So I didn't specify any value, but I added one additional index, but it had like not a number values. So there are certain things, certain operations in data frames. It's called fill NA. So wherever there is NA, it will fill it with the value 0, or you can fill it with the value 2. So, or you can fill it with the value 100. So this is really useful in data processing because when you're feeding a data frame to an algorithm, you shouldn't give it like not a number, because not a number, it will get confused. Like it can't compute. Like when you have NaN plus 2, it will say error. I can't add not a number and 2. So generally what we do is we do a lot of pre-processing. So we will say that we want to fill all the not a numbers in the data frame with the value 2 or with the value 0. Or if you don't want to fill it, you can just say drop NA. So when you give data frame dot drop NA, it will drop all the, even if it sees one particular entry which has NA, it will drop this entire row. So it will just delete that entire row. So these are some of the advantages of using data frames. You can cleanse the data and everything before you start working on it. So the other thing is you can do like ascending and descending of the things. There's also group by. So okay. So what you can do is, like, if you want to just print the first 2 rows, right? There is df.head. Head means from the beginning how many rows you want to print. So there is something called as the dot head function, which you can print the number of rows. There is additional cool thing about this thing is, let's show you. There's a group by. I think we'll spend some time on this thing. There's a group by function. So here I'm creating a IPL data frame. So in which I have the key as teams is Kolkata Knight Riders, and these are the people who won the IPL respectively in the following years. And then I have the ranks, I have year, I have how much was their points. So group by, what it will do is, when I give group by, it will just take that particular, it will group by the team. So if I run this, you will see that it will give you the result like this. So when I say group by the team name, so it will just, so for example, right, this is the whole data frame. So why don't we, but I have to send you this data. It will take a long time for you to create. Let me send you this data. So I'm creating, I'll send this to you in the email. Just check your email. So I just want you to load this data frame and group teams by their team name. So,
wait, Anna, I think it might be faster if you just put it in the chat.
oh
We
yeah,
can just copy it.
Yeah, that's correct. What about the chat? So, so this is a small data frame which I created with the names of the teams and then their ranks and their points. So load this data frame, and there's a group by option. So if you print group by the team name, so so this is the whole data frame, right? So if you see here, the whole data frame looks like this. So which year, how many people had how many teams. But if I give group by, it will give all the entries of Knight Riders together, all the entries of Devils together, all the entries of Kings together. So see, group by, Devils are present in this place. Knight Riders are present in this place. So let's just do group by, or try giving group by. Actually, write this whole function. So I've created a data frame called IPL data. And then in this, I want to group by the teams, and I want to print out the groups. I want to group by team and year, and also I can print out the groups. I can group by year also. Just print out this to have an idea of what you can do with this data frame. And once we are done with this, we will start our first case study and start analyzing the Indian liver patients.
Anna, what time does class end?
It'll end at 6.
Okay.
So we just have like 20 more minutes. I just will introduce to you how how you read the whole CSV file, and then I'll give you some assignments on like print out only like people with the disease, print out like just so that you get to play around with the data. I want you to be comfortable with how you handle like these data objects and stuff like that. Is everyone able to like print out the names by groups and everything?
I missed the import part.
Oh. What import? No, it's still pandas only. Import pandas as PD. What import part you mean?
This Indian liver CSV.
Indian liver. Oh, that's next. Let's just finish this thing right now.
Oh, okay.
So sorry, that was like, so I just want to like see how you can handle pandas data frames and everything. And then after this is done, we will, so now you're getting an idea of what a data frame is, right? So it'll read everything. You can read columns, you can read their names, you can read everything together. So after that, I would want you to like, after this is done, we will read the import Indian liver patients.csv directly. And then we will do some minor things like, print all, like print every someone's age which is greater than 65. We'll do some operations on the data set. Is everyone able to print group by and everything?
Yeah, we are able to. So one question is, what does this dot groups means? Like, I mean, from the syntax.
Yes, the syntax perspective. So what happens is you group by team, right?
Mm-hmm.
So when you group by team, how many teams are there? There are Knight Riders, there's Devils, there is Kings, there is Royals. So there are like 4 groups. So right, I first group by that, and then once I group by them, how do I access each group? I say dot groups. So group by will create groups within the data. So in this case, the team is the name, right? The column name. So in this column, I have actually grouped by the team name. So I created like 4 or 5 groups. Then I want to print out all the groups. So that's why dot groups. Once you give group by, it will create like groups of every team. How do you access every group? You say dot groups, you'll get this thing. So if you want to access the first group, you say groups of 1, groups of 2, groups of 3.
So if I don't give groups, it will just print without the group name.
Yeah, it will not print out each individual group. I think it will print out the type of that particular variable. But if you want to access like each of the group, right? So here you can actually say all the groups. If you say dot groups, it will give you like all the groups saying, hey, Daredevils, it is there in this index. This is that kind of this thing. So we can try that. Let's say if I don't give groups. Let me run this. This liver patients. So you see, it just says, so this is the, so if I don't give groups, it'll just print out like what that group this thing is. It'll just tell me the type of that variable. So it says that it's panda score group by groups. It is this object. But if I want to actually print out the groups, I'll just give the dot groups.
Right.
This is just to show you like you have other operations in using Panda, like in the data frames. You can group by, it's somewhat like SQL friendly. So you can split things, you can group by and things like that. So this is clear, right? So let's get into the first thing right now. We will, so I will introduce one plot right now. So I'll talk about something called as blocks plot. So first thing is, so look at, okay, what else you want to do box plot right now? Do you guys want to do some plotting? Like, do you want to see some graphs and stuff? How do we plot? I'll just do one plot. I won't do all of them because each one will take some time. So let's just stop data frames at this particular point of time. I will talk about something. So the way we are actually doing this is, first we are learning how to read the data from from the CSV, and where do we store it? What is the data structure do we use to store the data frame and stuff like that. But using this, the first step is basically also to visualize the data. So once you actually get this data, what are the graphs which are available, which will tell us a lot more about the data. So one such graph, which is very popular in data science, is called box plots. So I will cover the rest of the plots later on, but this is very interesting plot. So I've sent you guys one text file, right? It's called snowfall.txt. Please download that file. We'll be using that file right now. So box plot is something which looks like this. So if you can see my screen, so it basically looks somewhat like it has one bar here, and it has another bar here, and another thing like that. So what a box plot represents is basically, it represents where the median of the data is, what is the first quartile and what is the third quartile. I'll tell you what quartiles are. I'll tell you, like, looking at this particular plot, you can see the nature of the data. So let's take a small example. So basically, let's say this is our data, right? 92, 73. And if you look at this, you cannot basically visualize and tell how the data is looking. So I have a data which is like 92, 75, 81, 87, 85, and 83 and stuff. So what we generally do is we use box plots to visualize this data. I also want to as assignment, I sent one file called snowfall.txt. If you look at what the snowfall.txt contains, it contains basically the snowfall. This is basically, I think, millimeters snowfall. It has the snowfall of Whistler Mountain, and it has the snowfall of Snoqualmie Mountain for different days. So using a box plot, we will analyze, or I think maybe I'll give you that as an assignment. We'll analyze which of the following mountains should you go for skiing in the coming days. Generally, people go for skiing on mountains which actually have two things. One, it has a higher snowfall density, but also the thing should be constant. It shouldn't have like variation. Like one day, let's say if the density is 170 millimeters, and the next day if it is like really high, so that means there's a lot of variation. People will avoid variations and stuff. But anyway, so if we have the data which is like this, how many of you know what quartiles are or what median is?
It's basically the percentile, right? Like
exactly. So yes, first 25 and stuff like that. So basically, let's start with what a median. Whenever you have the data which is like this, first thing you do is you reorder the data in ascending order. So you basically take the data and then put it in ascending order. So 75, 81, 83, 57. So you put it in ascending order. Then you find the median of the data. So median is always the center of the data. So let's see, 1, 2, 3, 4, 5, 6, 7. It's different from average, because average means you take everything and divide it by the number of entries. That is average. Median is basically the center of the data. The center of the data meaning, so there are 1, 2, 3, 4, 5, 6, 7 entries. So in 7 entries, which one is the middle of the data? The fourth entry, right? Because you have 1, 2, 3, 4. So the fourth entry is basically called the median. So median is basically the center of the data. So then after you do that, the first quartile means 25% of the data. So which value, I mean, after up to this value, the data is 25% of your value lies within that particular range. So what that means is, if I take 81, so 75 and 81 are 25% of your values. 25% of your values lie either equal to or less than this particular value. Third quartile means, so first quartile is 25%, median is 50%, Third quartile is 75%. So 75% means like 75% of your values lie either at or below this value. The way you calculate this is pretty simple. The way you so for median, we just did the middle element in the number of entries, right? So for calculating first quartile, you just take all the elements below your median, which is 75, 81, and 83, and then you calculate the middle of that. So the middle of that would be what? 81. And then for the third quartile, you take all the values above your median and you calculate the middle of that. So this is 83, 87. Mind you, this is not the mid. It's not the mean value. It's the middle value. So in 87, 89, and 72, you will get the middle value is 89. So you get third quartile as 89. Is this thing clear? How I calculated the mean, median, first quartile, and third quartile?
Yeah.
So step number 1, you take all the data, you put them in ascending order, and then you take the median. Median is the middle value of the data. And then you take the middle value of the remaining data on this side. That will be the first quartile. You take the middle value of all the values above your median. That will be your third quartile. So now basically this is your median. This is first quartile. This is third quartile. So there is something called as, this is a very common term. It's called IQR, which is interquartile range. Interquartile range is third quartile minus your first quartile. So what is the interquartile range here? Which is 89 minus 81 is 8. So this particular box plot is generally showing that you see this middle line here. This is the median of the data. And then you see this line here. This is your first quartile. And this upper line is your third quartile. So is this thing clear? So you have this line, you have this line, this is this line. So middle line is the median, the bottom line is the first quartile, third, and the top line is the third quartile. So what are these things? There are some extreme points here, right? So this is nothing but, so what they do is they multiply it, they say it's 1.5 times of interquartile range. 1.5 times of interquartile range. So 1.5 times of interquartile range, that would be 8 times 1.5, that is 6, right?
12.
Sorry, 12. 1.5, 12. So you basically take this particular third quartile and then you add 1.5 times of that particular range above and 1.5 times of that particular range below. So that will be your extreme points. The reason these are called whiskers. So whiskers meaning like, in the whiskers are, cat has whiskers, right? Like on the mustache of the cat. The extreme ends are called whiskers. The reason why we are even studying this plot is because let's say if we add an outlier, right, to this data, let's say if I add 150 here, you see that it'll squish the plot will still remain the same, but then this 150 is somewhere here. So whenever we want to analyze the data, like let's say the snowfall data which we have, we'll do box plots for both Snoqualmie range and Whistler range. We want to generally avoid the ones which have like a lot of outliers. If we have outliers, then that means that the snowfall is very erratic there. There are two factors which determine people who go skiing. One, you should have a maximum snowfall, but at the same time, you should have less number of outliers because you don't want the climate to be very erratic. So this is one of the very fundamental plots which we have in machine learning. It's called the box plot, because looking at the plot will tell you how the variation of the data is. So if you see a plot like this, that means that most of your data is concentrated here, but there is some data which are outliers somewhere here. So that will tell you like if the data is like concentrated at one particular position or if you have like outliers somewhere. So is this thing clear? Any questions on the box plot?
No questions.
So generally we use box plots to determine how the data distribution is and stuff. So I just covered one particular plot right now, but we will see more how do we do that in the future. So the way we plot it is shown here, but you need not worry about this because I think we are almost out of time right now. We'll see box plot, violin plots, and everything later on. But the exercise for you is read this particular CSV file and then display every column name. So in this case, we have so so now here is how we read this CSV, right? We do panda pd.read CSV. It will take all the CSV and put this into a data frame here. So now when I do liver patient dot this thing, and then I want to just display the, let's say I want to display everyone's age. What will I do? I'll just give age. So let's say I want to find all the ages of people who are above a certain age, right? I just do above 50. So so you can basically manipulate the data as much as you want in here. So like one such scenario which I have here is in the Indian liver patients, forget about a scatter plot, but look at the operations I'm doing here. I want all the male patients who have the disease. So what I'll do is, so what will this give me? So I'm taking all the liver patients whose gender is male. So I just take that particular column and say double equal to male. This will return me the indices of all the values which are male patients. So I use that index again for this liver patient. So I want people who have disease. So people who have disease is 1, people who don't have disease is 2. I think I must have said the other way around before, but people with disease is 1 and people without disease is 2. So in this case, I want the patients who are male and who have disease. So the way I look at disease is I say this dot, remember the last column data set is the label. So I say that is equal to 1. So now this particular condition, actually write this down. So why don't we just read this particular, where is pandas basic? Read this particular data frame into this thing and then print out all the values where the age is greater than 50. So we first read the, so the way we read it is it's a CSV file, right? We do pandas.read CSV, we get all the values of patients who are there in the CSV, we store it in this particular data frame. So firstly, we want the age, right? So we say liver patients of this thing, and we have age. And I want all the people who are above 50. Do we have anyone above 50? Oh yeah, we have some people above 50. So this one will give you the indices of everyone who is above 50. So if I want to access the exact patient values, I'll have to call these indices, right? Or let me divide it further. So I'll say indices equal to this. And now I want to print out everyone who has this particular values. Yes. Is this clear? First, foremost, you basically create a condition on the age. You'll say all the patients who are above 50, store their values in indices, and then you print out those patients. So in this case, I actually skipped this step. I didn't create indices separately. So I put all this inside this particular function here. So that's why it looks like this. So if you see this, male patients with disease, firstly, I create the condition that they should be male and they should have the disease. And then the output of this is the indices of all the patients which satisfy this criteria. And I give them as the input to this particular data frame. So, but what you can do is if you want more clarity, you can just do like indices equal to this thing and just give indices. I think, yeah, just do this exercise for printing out all the people who have their age above 50. And I think we'll wrap up the class for today. Is this clear on how we read data frames and everything?
To read that file, do we have to give whole path or?
Oh yeah. So I actually gave Indian liver patients because I pasted that file in this particular. Yes, you have to give the whole path. So wherever that project is there, I put the Indian liver patients there. If you don't have the Indian liver patients there, you have to give the whole path. So I generally, that's a good question. Actually, I forgot to mention that. I actually put the liver patients thing here. So either you can do that, you can take the Indian liver patients and put it in your same folder, or you can actually give it the whole path. So we did some basic analysis of how we can read the data, how we can do this thing. If you guys are like, if you want to go step ahead, you can read everything and then find the, I mean, it's there in the slides. You can find the rank of the matrix. Remember, we did, the main thing which we want to do is to see if we want to consider all the features or not for analysis. So we can read the whole data frame and then calculate the rank of that particular matrix to see if all the 10 features are useful or not. But this is how we read stuff into, in machine learning, we read stuff into the data frames by using pandas. Any questions so far? We will continue with how do we do box plots and like different visualizations, scatter plots, histogram plots, and everything next class. That would be matplotlib and Seaborn. But let's spend enough time on data frames. Let's be comfortable with data frames. Is this thing clear? Is anyone having any confusion with this? Like so generally if you want to find out like two things, if you want to find male patients with disease, you generally give this, but this will return you back the indices. So you just take those indices and put it and then use the data. It might be confusing when you see why are you using the patient's data frame and you're doing this. It's only because this is a condition, and then that condition will return you back indices, and then that's why you will. Were you able to run it? Is any questions on these things? Are you guys still working through it, or?
I don't have any questions.
Okay. Yeah, maybe. So we just touched the basic of data frames, but I'll give you some assignment questions on data frames and stuff, so you can play around with the data and this thing. I'll send you my code also. If you have any questions, you can just refer to the code and see. But we'll be doing with two case studies. We'll finish off the case study on Indian liver patients, and then we'll do this case study on video game sales. So video game sales, this is actually real world data of Nintendo, Microsoft, and Xbox console sales. We'll look at different graphing algorithm, different plots. So there are like Seaborn has some plots, scatter plots and stuff. I didn't get a chance to like go through all of that today, but as I can show you, like Box plot is one of the plot. Like each plot will tell you different information. Like box plot will tell you how the data is distributed, if there are any outliers in the data. So looking at the data, can we actually make sense as to, don't worry about that snowfall example. We'll code it up and then we'll see which one has more. It's not just more snowfall, but it shouldn't have outliers also. And then we have like the other plots, histogram plots, scatter plots, violent plots, density plots, and then we'll see other different kinds of plotting algorithms next time. But at least today, the takeaway things are two main things. One, how do you read the data from a data frame into a data frame, and how can you operate on the data frame? That is one. Second thing is, when you have all this data, are all the features in the data important to you? If there are no feature, if there are some features which are linearly dependent on each other, then it is not useful for your system. So the way you find that out is by calculating the determinant of the matrix or the rank of the matrix. So in this case, I mean, it's just a bonus thing for you guys. If you want to like find out if all the features are making sense, the way you will do it is find out the rank of the features in the Indian liver patients, or find out the determinant of it and see. It'll take a long time for you to calculate the determinant, but just find out the rank so far and see if the rank is 10, that means all the 10 features can be useful. So we'll see the visualizations and everything in next class. So any questions so far? Because I think we are out of time, but was the class like useful in understanding, like how do you look at the features, like how do you pick up features which are relevant, how do you read the data into a data frame, how do you process the data frame? We'll do some more things. I think next class we'll do a lot more things which are going to be data analysis. I'll give questions as to how do you cleanse the data, how do you apply like some processing to the data and stuff like that. No questions, then I think we'll stop the class today here. But if anyone has questions, feel free to ask me. If others, if you want to drop out, you can.
Okay, thanks. Have a good one.
Thanks, Sai.
No problem.